Hello. I don't know what they had this thing here. It's like in the way. Maybe I need to move it. Okay. All right, let's go. So today I think that I want to do something different. I want to do like some kind of dungeon generator so that we can get some a little dungeon going. So goal is generate a dungeon, put a bunch of monsters there, and perhaps get to maybe getting some loot or something. So I'm thinking for dungeon generator, well, really, I already have kind of like I have like a location system, so I can generate essentially any type of grid, like tile map thing, with solid walls or stuff like that. So we kind of already have the kind of architecture to just add a new map that can be generated, a new type of map essentially, because we have this map thing and we have generation type, because we have like a generation function somewhere, generation type, and then based on the type of generation it's gonna generate a different thing. But then we have a bunch of other information here that like width and height and seed and all that. Now potentially what we could do is generate like okay, so I guess there's like different approaches. There's like a million ways to generate dungeons, I guess. I've been looking shallowly on a few things. Hello, bar checker. What's up? No penguin? Well, I just started. Sometimes penguin shows up after a little bit. I don't know. We'll see. So yeah, so either just generate directly into the grid and hope for the best. There's also other ways where you have like several steps where you first generate kind of like a structure that is not really, well, that could be any kind of structure really. And that doesn't have to be like a set grid or anything like that. It's just maybe it's a graph that explains like the different connections between rooms before even generating rooms, and then you try to kind of follow this map. And I also looked at wave function collapse, although that seems like the kind of algorithm that I looked at seemed to be pretty slow. I don't know. I know that Caves of Cod uses like a mix. They, from what I've seen, I saw that talk on that. They use like a mix of wave function collapse with other maybe more traditional generation, where I think they used wave function collapse in generating like houses, structures in like a village or something like that. I don't know. I think also there's, well, yeah, and then there's like this, I guess another traditional way would be you have a set size Because for ADOM, for example, you cannot have a larger dungeon. It's like every screen is a set size. It doesn't have scrolling window, so it's like every screen has a set height and width that you can fit things into. And when you generate a dungeon there, or a level, or a floor, it has to fit within those constraints, essentially. How's it going with the project, Brochecker? Need to fix some VS Code extensions? Oh, really? VS Code. I was right. Do you also have to use like Xcode to some extent? Because I believe we had to use Xcode to kind of connect to some Apple dev account or something like that. You had to go through Xcode. I'm not sure. I don't know if you have to, but that's the way we did it, I guess. And you had like a team or something like that. I think we used it to get certain artifacts access, I guess. Only if I need to connect Apple Account for notarization first time. Okay. I just use Xcode CLI. Alright. Yo, Penguin! What's up, what's up? Okay. Alright, but I'm thinking. So that means like potentially we don't need to start out with like a width and a height, is what I'm saying. Like we could potentially generate any size dungeon, essentially. Or we could try to have the width and height as like a constraint. We set like, okay, well, you can be maximum width, height, and that's it. And then we try to keep that as a constraint. So maybe like if a room is generated and it's like outside of the thing, it's gonna be removed. I mean, I might look at, like, I just want to have some type of dungeon right now. And then we might look at, like, improving the algorithm later. Like, trying out different algorithms. Because I really want to have, like, different types of dungeons as well. The thing that I'm looking for right now is just a super basic square rooms with interconnected corridors, essentially. Okay, but let's do like this. I'll add like dungeon. I guess dungeon, I'm not sure if we need noise, really. But whatever, let's find out. Yeah, town is really not... We don't have a generation function for town. It's actually, it's hard-coded. Okay. I mean, we could use noise, perhaps, as maybe, I don't know, you can use noise for different things. Like you could use it as a map to determine different properties of rooms, for example, maybe. Okay, but what I'm thinking now, okay, let me diagram this. I was thinking first that I wouldn't diagram this, but here we go. No. So what I'm thinking is this will be the kind of size of the dungeon here, let's say. Radom here. And then this is like it's a grid. Yeah. So it has like a width and height. So what I'm thinking is maybe we start out at the top left and we generate like a room that is a random height and width, essentially. Okay. And then we just go to the right of that room and perhaps with a bit of padding, maybe. And maybe we generate, or we do like this. We generate first another room with random height and width. Maybe like this. But then we also generate, then we take like random bits off. So maybe we shave off this part here. So it's like, well, the top is shaved off, or Y is shaved off. Yeah, the top, and then maybe this is shaved off. So now we have a room like this. So this would be the final room here. Something like this. I don't know. I'm just winging it here. Okay, and then repeat the process and we'll end up with a bunch of rooms like this. And then once we're at the end, we will go back, find the first available spot and kind of repeat the process. The problem, I guess, here would be that we might actually get to places like this where it's like colliding. But maybe we'll do like, because I was thinking like rows and columns. Maybe the rooms are like rows and columns. They will be very static though. Like the grid is like this size, let's say, but then the room kind of grid is like this. So then so then like the room cells will be larger like this, perhaps. And then we go through each room cell and we can like determine, okay, should you be a room or not? Something like this. So do you want to be a room? And then we generate like a random size in this room. So it can be like a small room or a larger room. And the position would be random. So it would be like one room per thing like this. Or maybe no room in one of the things. Maybe. And then perhaps we try to generate like a corridor in between each cell. Yeah, that would be super basic, right? How would the corridors work though? So I guess if we're like here, we would know that, okay, we're at the top, so we don't generate a corridor top. We don't generate a corridor to the left. But here we're like, okay, let's take like some wall portion to the south. Go down. Once we get to the midpoint, maybe, or at some point along the line, we turn to match the entry point over here. That should be super simple. We just pick a spot on this wall, pick a spot on this wall to connect, and then we just draw a line, and at some point during the line we do a turn and then this. That should work, right? Because there's no, it's gonna be like this, yeah. And then here is like, yeah. So there's not gonna be any collisions because, well, actually technically it could be a collision. What if this room here is kind of large? Like goes all the way top. And then this room goes all the way like this. Well, this room, the top one won't go past this point. No, there's no collision. I don't think there's a way for this to collide. It kind of looks like it could collide. Wait. What if this is like this? And now we have this down here, and it like crosses over like that. So there you have actually a crossing. But I guess doesn't really matter because the corridors are simply like empty spaces in the walls. So this would just mean that we get some crossings here. It doesn't actually matter that much. Yeah, okay. Let's do it like this. Just a super simple dungeon generator for now. So we'll have like room size is going to be the size of the room grid, or room cell size is like how large can a room be? It's like one of those room cells. And I guess that could vary. Like we would have to just decide on something here. So I'm gonna say it's a vector of how many tiles do we want it to be? I don't know, maybe 10 by 10 or something. We can change it. Okay. So we have the cell size, that is like the maximum size a room can be, essentially. And then we could have, and then I guess essentially what we could do, we could loop through all of the cells, the room cells, and just generate a random room in each one, and then try to connect them up to the other rooms. So we'll do 2 passes, I think. So, and we need like the actual room generation as well. So what I'll do is I will create a list of lists maybe, or just one list. No, we just need one list, yeah. So we'll create the rooms will be, we don't have an allocator here. Oops. Yeah, let's just pass in the allocator. What's this? No Haskell. I have Haskell on the other screen. By the way, I kind of made this work here with when, but I had to kind of make my own combinator thing here that fits the when. I mean, it turns out when is like kind of weirdly, well, it doesn't really fit a lot of patterns, I would say. But it's like we just map when over this because this is a, you know, it's an IO. And then I did this combinator here, which basically applies the resulting function through, because how it is like you have an IO result with a function that works within IO essentially. To give you an FP. Couldn't we, I mean, wait, couldn't we just do bind? No, wait. We need to get this out of here. This function out of here and then bind it. No. I mean, the other way is to, like with built-ins, is to do this and then use the apply operator like this. This also works. And this would be like built-in. So essentially saying like, we want to bind essentially this. So we grab out the inner function, which works in the monad. And then we just apply loop ref to this function to give us FP. So that's how that works there. And then I did this, yeah, so that's what I did here. Actually, I just made this combinator, essentially. So my goal was basically to be able to use when with monadic values as like, it kind of looks like a normal function application, but you have to use the correct combinators. That's what's, you know, makes, it's kind of cool with Haskell that you can do that. But it also, the problem is, okay, how do you find the correct, like just looking at this is kind of, you understand kind of what's happening. And that's all, like you get this higher like bird's eye view, but then if you want to go into the details of what's happening, then it can get messy, you know. And then I can do the same thing here. This one is like, when is key down, key W, do this, right? It looks pretty straightforward now, but you have to use the correct combinators. So this is the kind of nice, elegant code that I'm looking for, but yeah. It takes a little, like, if you're not used to it, it takes a little time to actually find things. But we're not going to do much Haskell today. I don't think. I want to continue with this RPG and make a dungeon generator here. All right. Dungeon generator. So the rooms would be, we allocate a bunch of rooms. Let's just make a new thing called room. And we need this many rooms. And let's just catch unreachable on this one. And this should give us a list of T's, which are rooms. Let's make a room struct. And yeah, so the room struct, I think it needs like an offset for the grid. Or even an absolute position, perhaps. Or both, I guess. I'll add both for now and we'll see what we need. And then a size. Okay. So we'll simply go through all the, I mean, I guess we can just go through all the rooms, or we can go through like X and Y, height, width and height. Yeah, let's do that. Dungeon generators are cool too. Yeah. I'm just making a super basic one so we can get something out there and we can like go through and yeah, populate with enemies and stuff like that. Maybe get like loots. Maybe we'll add like a chest that we can open or something like that. We'll see. Okay. Width and height. So the index is gonna be x plus y times the width, and rooms index would be equal to a new room. I'm essentially just gonna make a function like random room, and we put in the max size of the room, and we should probably also put in the position of the cell. So let's put that in there. Okay, so random room. Also we need, actually instead of allocator, let's just put game in here. Because we need game for random stuff. All right, random room. Position. And max size. Gives us a room. Okay. So let's randomize the actual size. I think this is an I32, yeah. I32 2. What do you use to randomize? It's just random bytes. So it can be essentially anything. Is that what you're saying? Let's actually do it like this instead. So random int range less than, no, at most, I guess. So at least would be like the min size. I guess we could put min size as well. Let's do like, I don't know, 3 by 3 or something. So min size x, max size x. Min size y, max size y. Do you work with vectors as well, by the way? No. All right, so that's the random size. And then we need like a random like offset, which is kind of like, yeah, let's do like random and then like min offset. But we need to kind of, okay, what is min offset? I guess it's 0. That should always be like 0. What is max offset? So this is what I'm thinking, like max offset should be guaranteeing that we don't overlap into the next grid cell. So I'm gonna say it should be like max, I guess max size minus size or something like that. All right, so we have offset, we have size, position is position plus offset. Oh. Position. To int. Okay. So now we should be generating these random rooms. And now, so yeah, so now we should have all the random rooms. Next up is generating like the connections in between. So I think the properties we need is like, where does it start? Where does it end? And when is it, like, when do we decide for it to turn? So let's do intersection, or corridor, I mean. Start position. End position. And turn position. Or, well, it really, it doesn't need to be a position, it can just be an index. It's like we go along to generate the actual tiles. We go along like we start at start and we increase index. Basically, I guess technically we could have like a step to know which direction we're going. So every time we increase the index, we go one step. Once we reach a turn index, we will generate I guess we need like a turn step. I mean, this could all be like calculated, but let's just put it here for simplicity. And then we go to turn step until the cursor reaches how many turn steps do we want? Like until we reach, yeah, I guess that would be, so turn index is like turn start index, and then turn end index is like when should we turn back, right? So essentially, first we start at start position, and we keep track of how many times have we stepped through. Each iteration we step, and the type of step we do, we start with the step. When we reach the index of the turn start index, we start to do the turn step instead. Until we reach the end index, in which case we go back to step until we reach the actual end position with our cursor. Okay, that's the idea. Super basic here, but yeah. And I guess we would need like a random corridor as well. Now the corridor needs I guess like 2 rooms essentially. Room A, room B. And we need to calculate like maybe we can put in a direction as well. Like the relative direction from room A to room B. Because it's like, it's not obvious from this standpoint, unless we know the actual grid cell, like the room cells there. So we need like a relative direction from A to B. A to B, we need a direction, so I guess that could be in terms of a vector, perhaps. Okay, so what we need is like start position is gonna be like room A, the start position of when room A starts, end position, these are gonna be like the walls, one of the wall points of the thing, depending on like A to B there. We are going to need step. I mean, yeah, we're gonna need all these things essentially. Turn step is like, I was thinking doing some kind of, you know, high, like top, what the hell is it called? Top-down programming here, but okay, so start position, essentially, it's gonna be like the wall of the room, the wall of room A, room A's wall in the direction of A to B, and then a random point on that wall is what we want this to be. Okay. So A to B. So how do we get that? It's like A to B should always be either like X is positive, or I guess it technically might be able to be negative as well. But it's either gonna be, and then Y is 0, or the other way around. X is 0 and then Y is not 0. So it's like if X is not 0, then we're gonna pick like one of the walls along the height of the room. So we take the height of the room, like randomize essentially. I mean, we could do this, I guess. If X is not equal to 0, then we're gonna pick a random let's do int. Yeah, because uint forces this to be an unsigned integer, I think. Let's do like int less than I32 at least 0, less than room A size 1, because we're moving in the X direction, so we need to pick the height wall, the vertical wall. Okay, so we pick a point on that wall. And then, so this would be like Y relative to like the top position there of the thing. So let's make this, U should be a bore vector, and this is the Y component. And what's the X component? X component will be, depending on like if A to B 0 is positive or negative. So like if A to B 0 is -1, or I guess it's less than 0, then we're moving to the left. So we should just take, this should just be 0 relative to the wall position. So it's going to be like room A position 0 plus 0. Otherwise, it's going to be the width -1. Yeah. Actually, then this is just a step, essentially. This would be the step. Yeah. This is just step. Okay. Otherwise, we have the step goes in the Y direction. So now the Y is random, or I mean the X is random based on the width. Wait, the Y should also be offset by position 1. Yes. And actually, we can essentially just take position plus whatever we get here, so then we don't even need to put these here. And then if Y is less than 0, otherwise we do this. Okay. That should be the start position. And then the end position is basically the same. It's just that the step is like negated, essentially. So what we could do is move this out to a function. Get random wall point. And we have a position. I mean, I guess position, we can add that before. So this would be like the room and the step. And we need random. Okay. So basically, start position is going to be room a position plus get random wall point room A and step. Okay, and then end position will be B plus get random wall point negative step. So then we go like in the opposite direction. Okay, so we have start position, end position, step. Turn step is just going to be like step, but it's like rotated, right? So it's going to be but which way is it going to be rotated? So turn step is going to be it's going to be, I think it's like negative step. No, wait. So like step 1, 0. Now it's kind of rotated, but it always rotates. So let's go through the case. So basically, let's say this, it depends on the difference of y of this, or difference of these points. So I would say like relative would be, is it end position minus start? Yeah. Yeah. So so turn step would like be based on this somehow. So it's like if the relative, if we move to the right, for example, and then the start is like higher up than the end, then we need to rotate down to get to the end, right? So we need to rotate, yeah, then this would be correct here. So this would be correct in the case of going to the right and then going down. However, if we're going to the left and we need to go down, then we actually need to negate this, because then we're rotating the other way. I mean, I could just make a giant switch or something. A giant table to work this out. I'm just trying to think if there's like a more concise way of doing it. So it's like it depends on the sign of x. If we go down, so if we want to go down, let's think about it like that. If we want to go down, so basically if this would be one step towards the real thing. So if relative 1 is more than 0, so that means we want to go down. Then if we went to the right, we just keep the sign. If we go to the left, we want to negate. So essentially, we always want to make it positive. So this would be the absolute. Otherwise, we want to make it negative, I guess, because then we want to go up. No, it's this one here. This would be X, right? Then we want to go up. I mean, essentially, step doesn't matter. That the value here, like this would always be -1 here, or I mean, it would always be 1. No, actually, because if X is 0, we actually don't want it to be that. But this one would be like negative. This one we're gonna flip after we have the thing, right? And then this would be the same thing, except we are working with 0. If 0 is positive, that means that we want to move to the right. Otherwise, we do the same thing. I think this should work. It just, yeah. I guess it's like times the sign of... Okay, so what if relative... So what if we move to the... So, okay, what if we move to the right, we turn down? Then the turn step needs to have X be 0. Which is, it is 0 because step 1 should be 0, yes. And then the other way around. Okay. So now we potentially have the turn step. Okay, now we just need to the turn start index. It's actually pretty simple. It's just going to be one random number but in between start and end position. So essentially what we do is we say like so we would take like relative times the step. If we take relative times the step, we would get only the portion where we're actually moving towards. So relative times the step. If we're moving to the right, for example, the y will be 0, so y would be zeroed out, and we only keep 1 to the step. And then relative would automatically also be x would be positive, because the difference would be positive there. In the other case, where x is where we want to go left, then step is -1, but this one would be negative as well, because now we want to, now the difference is like to the left. So this would always be positive, essentially, in the direction that we need to go. So what we do then, I guess we calculate we just take, we just do the sum of the components. So we'll do like max turn index would be reduce. We just sum all these, we sum them up, and that would be the max turn index. And then we would say turn index or start index is game random int range at most, I guess, at least 0, at most max turn index. Now we might also have a little bit of padding here so we don't get like a turn immediately. So we could have like min turn index as well. Let's say maybe 2. Let's do like min of 2 and max turn index so we don't mess things up here. And this would be min turn index. Okay. Start index. Now max can also be like we have a little bit of padding at the end. What if we say, well, this would be like the step distance, and the max would be turn index. No, it would be like max or min. Wait. Yeah. It would be min of step distance minus 2. And I guess 2. Wait. No. So what I'm trying to do is just add a little padding to the end without it going past a minimum distance. I guess it would be max here instead. Yeah. But then what if step distance is like less than 2? I guess we would have to figure that out. Okay, well, we could add like a little padding. We could add padding between each grid so that, yeah, we could probably do that maybe. Okay, anyway, or between each room. Now we have like everything except the turn end index. The turn end index is calculated from the difference in relative in like the rotated step, like the turn step. So it's going to be like relative times turn step. So basically if we move down, if we turn down, then this would also be positive, because if we turn up, then this would be negative. So this would that's the same idea here. It will always be positive. So actually this would be the max. No. This would actually be, we reduce, we add. So that will be the same thing. It will be like, you know, the distance to that. Kind of hard to explain here, but the distance to the difference in the component that we're not stepping into. So that is the number. Wait, is that just it actually? So let's say the distance is like 5. We need to do turn step 5 times to reach the correct level or position. And then we turn again. Now we're using the step until we're at the end. Yeah, okay. Let's go with that. All right, so now we have a way to randomize the corridor. So now we need to loop through all the rooms again. And we need to pair the rooms up. So essentially we go into each room. We will get room A will be the current room. And I'm thinking maybe we should just pair with rooms that are to the right and to the and to the down. because then, you know, each room will pair with another room, so then we don't need to look for other rooms left or up because they would already be connected. So if you start at the top left and we connect right and down, eventually every room would have been connected. So room A would be rooms I, and now we have to check, like, if x is more than 0, that means that we can now connect to the right. So yeah, we need corridors as well. Now, how many corridors do we need? We need 1 in between each room. How many is that? The number of rooms is rooms.length. We need, like, okay, how many rooms do we need, or corridors do we need? So for this one we need 2, this one 2, and this one 1. 2, 2, 1, and so on until we're here. This needs 1, 1, 1, or 0, I mean. So the ones that are in here all need 2. The ones that are here need 1. The ones that are here need 1, and this one doesn't need anyone. So it's going to be this part times 2 plus this plus this. So essentially width times, or width minus 1 times height minus 1 times 2 plus width minus 1 plus width height minus 1. I did it the other way around, but yeah, you get the point. That is how many corridors we need. Corridors is gonna be so what would you say? Width minus 1 plus height, or times, I mean, height minus 1 times 2 plus width minus 1 plus height minus 1. Except it's the wrong. It's the wrong. No, it's not the wrong. Actually, this is wrong. We're creating like tile number. This is wrong. Number of rooms is not width times height. It's not width times height. It's like width. Okay. Tile grid size is width height okay, that is tile grid size, and then we have room cell size, then we have room grid size. Room grid size would be tile grid size over room cell size. And the number of rooms is simply now reduce multiply room grid size. So that is the number of rooms. Okay. And then you are room grid size minus one, but it's a scalar, so we have to do like board vector 1, 1 times 2, which is also a scalar, so we have to do board vector 2 All right, room grid size times 2. But then we add another pair here. So basically we no, this is wrong. We need to reduce this and add, no, multiply. There we go. So we multiply size -1, -1. Right. And then we scale it by 2. And then we add. Okay. Then we reduce. We add. This again. So I'm gonna make like room grid size -1. And put that there. Okay, this multiplied is like, you know, width times height times 2, and then add 1 more. I'm just thinking like we should be able to just add 1 more then, right? Actually, you know what? It's more like, okay, this -1, -1 times 2 plus -1 plus -1. X -1, 2 times x -1 plus x -1. Isn't this just... No, but then we have also this. I was thinking if we could simplify this. Man, this basic math is not working right now. Because if we just put this, I don't know, man. No, I'm not gonna do this. This is just gonna have to be how it is. Okay. Cool. So this would be the number of corridors that we need. Okay. Great. Okay. So now down here, I'm gonna go refill my coffee. I'll be back in a second here. Oh, thank you, Julian. I'll look at that when I come back. Kirby. All right. What's in? This. Okay, so what we have is we have this. Plus. No, -1 plus equals the number of corridors that we need. Wait, divide, no, plus, you're saying plus, right, plus. Yes, that is correct, that is correct. This is, we could, yeah, we could just do this, and then -2. Which -2 essentially, -2, I mean, essentially we could take this -1 as a -2, right? But then we're stuck. If we're gonna move these in here, we're gonna have to like divide these by 2. Yeah. Anyway. Okay. Right. So back here. Now we need to make the corridors. So we will say corridors I, except it's not I. We have to keep another thing called J around for the corridors. So corridor J is going to be equal to a random corridor with room A and room B, and then the step. Okay, so we need room B and step. Now room B should be rooms I plus 1, essentially. That's what it should be, because I plus 1. No, hang on. Actually, we don't need to go through the last column, because no, we do need to go through the last column. We just have to have a check here. Yeah, we have to have a check to see, are we at the last column? Then we don't do the export, right? So x should be, wait, more than 0? No. It should be less than Also, this is not width height. I just realized this is room grid size. Except they are actually not. And I have to int cast. You know what? Let's do like this instead. To int we're doing a little bit of casting here. So it's basically the room grid size. Okay. There we go. So random rooms, random corridors. So for here, we're gonna check if it's less than W minus 1. That means that we're not in the last column. And then we have another one for the other one. But let's see. So the room B is I plus 1, which means, well, since this check is here, we always have I plus 1 in here. So that is room B. Now we need to calculate what is the step. The step should just be... The step here is simply gonna be... I mean, I guess it's always 1, 0 here. It's always positive. So we're never really gonna have a negative step, essentially. Okay, and then if y is less than h plus 1, now we're looking for I plus width. Whoops. And then this would be 1, 0 instead. Okay. That should be all the corridors. And whenever we set a corridor, we should also increase j by 1, I would think. Okay. What's this? I32 found U32. U32? Are you turning it into a U32 from I32? Or what? What? Are you serious? Wait, do you expect it even if we do this? Do you know what it should be? Okay, well then we do an int cast, I guess. Oh man. Like if I was new to Zig, I would feel so bad doing this, but and you know, I've gotten used to it. Unfortunately, it's like one of the things about Zig is like, yeah, it's nice that it's like explicit, but it's so much noise to deal with the casts. I guess the good thing is it kind of forces you into thinking about what, you know, what is a good fit for the data types. Sometimes you just give up and just, okay, let's just make everything like, I don't know, a float 64 or something, and I don't have to deal with a bunch of casts. Everything is float 64, and then we just, if we want an integer, we floor it. And then you don't have to deal with casts. Okay. You are... Okay, you... I guess... I use size. But now... Okay, now we have all the rooms defined, we have all the corridors, so now it's just going to be a matter of looping through all the rooms and all the corridors. Couldn't put the dungeon together again, but we will, yeah, go through them, basically generate tiles based on where they are. I'm thinking we're doing the rooms first, and then put the corridors, I don't know, something like that. Let's loop through all the rooms first. And then the room is rooms I. Technically, we don't need the room information afterwards. We can actually just free rooms and corridors. I was thinking of maybe like if we need to debug this, maybe it works the first time. If we need to debug it, like either we could just dump out all the information, or we could show it in real time, step by step, how it's generating or something like that. But okay, so rooms I. Now I guess we'll simply like loop through from room. Let's just do like room size 0. And of course, you are I32. Okay, so now we're in the room thing. Now is the question, okay, should everything be a floor, I guess? Or is it gonna be walls around? Like if we're... I guess we'll do walls. No, but because if it's a 3x3 room, then the walls would be covering most of the room. It would be just a 1x1. But then we might... let's just do walls around, I guess. So actually, we need to add 2 here for the walls. We could, I guess we could just do the walls separately, actually. Yeah, let's just do separate for those. So it's like we do all the walls. We go through like the size, yeah, we go through like size 0. Do we need to add 2 here? I think we need to add 2 for these. Okay, these would be the the north and south walls. So like, what is this gonna be? Oh, actually this is W, not width. Good catch, thank you. All right. Now the tile index is Rx plus room position X and okay, my brain just froze. Right, X is right. We're making northern walls, so it's going to be position thing plus position Y. Actually, you know what? Room top left is room position. It's just room position. I mean, yeah, it's the same thing actually. Yeah. Okay, and this would be times width now, because now we're in tile land, right? Yes. Okay, so the tile I is equal to something, floor or wall. Floor, wall. It's more like a I guess this is a dungeon wall. Dungeon floor. Let's do that. I have to have like a better system for this, but all right. Feel asleep, what did we accomplish? Well, I'm currently setting the tiles based on the room. So basically now I've done the room generation. We're generating like descriptions of rooms and descriptions of corridors. Now I just need to like paint the rooms onto the tile map, essentially, is what I'm doing now. I also almost fell asleep. Okay. So we paint the tile with this. So this would be the north wall. And then we have the south wall is the Y plus the size. Size 1, -1. No, it's just, actually, it's just plus size, actually. Yeah. Or is it even +1? Yeah, it's +1, actually. That's the south wall. Can I see it? It's not visible yet. I have to connect it to the rest of the stuff as well. I need to add like a location that you go in, and then that generates this map. It's not that much. I just need to tie up the knot here. Okay, now these are dungeon walls. So we do this north and south wall. And now let's do the east and west. So west wall and east wall. And this would be that. And then this goes over here, but you are 0. We don't need parentheses. Okay, cool. Actually, this is ry. We could do like left, top, left plus top times width, and then bottom. Maybe a little bit easier to think about. All right, let's do the same thing over here. So here we have like left is just position 0. Top is now ry plus this. And then we need right is position 0 plus size 0 plus 1. And then west wall is left plus top. East wall is right plus top. Okay. Now we should get like the rooms. It sounds way better when you're closer to the mic. Oh, I see. That's good to know. Thank you. How about now? Like, I'm not sure. I don't have like professional equipment. So I'm not sure how much like weird sounds you're picking up if I'm this close, but yeah. Okay. Well, we could potentially, if we connect this up now, we could potentially see like the dungeon walls. I'm just gonna add this here as well. Let's do like L left and top. And then index will be left plus t times width. And then this is a dungeon floor. It's better not so close, but as far as when you're laying back. Okay, like this. Maybe. Okay, so then we've discovered there's like an optimal distance. Oh, thank you, VVQ. Thank you for the follow. Welcome. How's it going? Vim user spotted immediate follow. Yeah, of course. Actually, it's NeoVim. But, you know, same thing, same. But you probably knew that. I guess we'll do +2 here. Yeah. More of a Helix guy, but I started out in Vim. Time to go back to lazy Vim. You should try NeoVim. Like, if you're used to Vim, I feel like NeoVim has the potential, like... of feeling... I don't know how much updates they do to Vim nowadays, but when I used Vim, I had like... I'm not sure how it's pronounced, but it's like ALE or ALE for like... If you would have to have like async... what's it called? You know, linting or whatever. Async diagnostics. It was like a little bit of a hassle, not gonna lie, to have that working. And also sometimes it just didn't work properly. And that old, I guess, you know, maybe now it's like an old version, but then like the async stuff of Vim was barely, you know, existing. But in NeoVim, that's all like built in now and works, you know, a lot easier. Heretics, all of you. What are you talking about? What do you use, Joseph? Do you use Notepad++? Or Ed? Do you use Ed? Or do you use Vi? Or maybe Nano? Good old Nano? I use the one true text editor. Okay, and what is that? Notepad. Original Notepad. That's the one I started with. Incompatible... oh my god, Emacs. We got a cultist in here. No, I'm just kidding. They can't be all bad, right? Man, these casts. Alright, let's do... Position should be... I mean, it should be in positive anyway. Oh my god. VVQ gifted 5 subscriptions to the community. Oh my god, thank you so much. Wow. Holy crap. And a hype train started. Holy crapperoonies. That's awesome. Thank you so much. That basically never happens here. Emacs user got the sub. Alright. Cool. Yeah, thank you, thank you. Did we reach like a goal? I think we're like 2 off or something like that. The first 10 subscribers. I don't know. No, 3 more. Okay. Nice. I don't know what happens then. It's just a counter thing. We have to bribe the cultist to... It's like the Inquisition here. What happens when... I don't know what happens. I guess we'll find out. It's gonna be like a little... Oh my god! Thank you! An anonymous user gifted 5 subscriptions. Holy crap, what's happening? Thank you. We're beat of all-time high. What's it saying? Level 2? I think that's the hype train. I don't know, it... There's some kind of... Something is happening. New sub-skull of 10. Thank you. Holy crap. I mean, I don't know. I think it just... I guess there's some level ups. I have no idea how this works. The new goal is... I mean, I think it's like automatically... calculated here somehow. I have not set, it's not me setting the goals. It's like built into Twitch. I think the followers goals increases by 10 every time or something like that. Hype train level 3. I think this is the hype train level 3. Oh, there's like emotes and stuff. You get you get a bunch of emotes, I think. Okay. Well, thank you again, everyone. Awesome, awesome. 10 subs. Holy crap. That has that's more than I ever got ever. Yeah, we just have to do this. Let's make you use size incast. Okay, let's make some dungeons. You get to quit your job now. Yeah, exactly. I mean, 10 subs. Let's say I get 10. I think I calculated at some point how many subs I would need to quit, to like live off. Like, what do you get? Like a couple of dollars per sub or something like that? So if your goal is to maybe I want, like, let's say, I don't know, what would be the minimum wage? I mean, just super low, I guess, let's say $1,000 a month. That it won't be enough, but it will help a lot. So it's like 1,000 a month. I mean, isn't that just like 1,000 subs essentially? I don't know. But yeah, regardless, thank you so much. I mean, I wish this was my job. I think you get $2.50 per sub or something. Yeah, maybe something like that. Yeah, it's like a couple of dollars, something like that. Cool. Okay, so maybe then, well, like 300 subs, maybe you will get like maybe $1,000 per month or something like that. Yeah. But then, of course, you have things like I think the most that you earn through, if you're doing like YouTube or whatever, is gonna be like sponsors. I think is like if you get enough views, you start to get sponsors, and that's where you actually can get money to live off of this, I think. Unless you're extremely popular on Twitch and you have like thousands of subs. Yeah. URA usize. Oh, well, we can just do intcast like this, actually. Are you you're a usize? Yeah. Man, it looks so good. Now it's all messed up here. Twitch doesn't pay for views. Well, it does. There's like a tiny ad revenue. I've been streaming. Okay, so I can share this with you here. Including subs, before these 10 subs here. I've been streaming for like 2 years at this point, or something like that, or 1 year. Let's say 1 year at minimum. And I've had like, I don't know, you know, in the beginning I barely had any viewers, but in total, like now I get like maybe around 5 to 10, 5 to 15 sometimes. But I've gotten like in 1 year, I've accumulated, including like, I think it was 3 or 2, well, couple of subs, but it was like $40 in total in a year. So, yeah. I mean, if I'm not paying any rent or internet or anything or food, that is it's not good either, even then. But yeah, that, so basically ad revenue. Well, maybe that was a bad example. If I go to my, like, what you actually, like, okay, so yesterday I got 36, is it cents? Like 36 a hundredth of a dollar or pennies or whatever is it? Cents. 36 cents from ads for, I'm not sure how many viewers there was. Yeah, but it's not a lot anyway. It's not a lot. Like, I don't run any, like, I don't press a button to roll ads, or the only ad you're gonna see here, I think, because I've turned everything else off, is the initial ad sometimes that you get when you start to watch. Because I can't turn that off. Because I would rather have people join, engage with that, and like, you know, have a good time and not have like ad breaks if I'm not gonna get anything for the ads anyway. So it's like, it feels very counterproductive to enable ads, to be honest. Yeah, that's what's happening. Okay, where are we now? You also want to be a U size as well. And these are all U size, so, and you are a U size, okay. Soon we'll have something up on the screen here. I promise. Right. Okay, now the question is, what about the rest of the tiles? Should we go through all the tiles and make them something? I don't remember if we just allocate them and that's it. So we need to go through, I think what we'll do, we'll just go through all the tiles first. And, well, we could just do this for tiles, tile, and make it into empty or so, or wall, maybe dungeon wall. No, that I don't think we have empty actually. Let's add that empty. Oops. All right. All right. Is solid empty false? Dungeon wall true? Dungeon floor false? And here is draw. You are just an empty thing. We need dungeon wall dungeon floor. Okay. Ads completely block out a stream on Twitch. I think YouTube's a bit better about that since you can jump back to see what you missed. So far, I like the stream because all the devs of the Unity and Godot. Yeah, most people. Yeah, thank you. By the way, most people I've seen uses Unity and Godot. There are like a few just straight up programming things. Also, I think. Man, I forgot the name now. But there's one channel that actually does Godot, except using like C++ development and not using like the interface so much, but uses like the Godot as an engine while programming like everything essentially. I want to try that sometime. C++, which is meh. Yeah, okay. There's not a lot of Zig, I would say that. There's not a lot of Zig developers that stream, as far as I know. At least on Twitch, I guess. Okay, let's see if we can find these things. Let's look at our dear old tile map or tile set thing. Sprite sheets, whatever. It's over here. We have floors. I guess we'll take like, what is the empty one? I think this is supposed to be like a wall background or something. I will pick this one for the empty. I mean, it's just black, so it makes sense also to not draw anything if it's empty. But whatever, you know. The way I've set it up is I don't allow for, you know, this just, yeah, this should be good. 3, 13, 14. So I have to put something in here. Otherwise I have to change this whole pattern. I don't want to do that. Okay, and then dungeon wall. Interesting. This could be it. But that's like dark though. Maybe one of these. Actually, there's not a lot of dungeon stuff in here, I just realized. Let's just pick like one of these, I guess. This one. That's the dungeon wall at 1427. There's literally another one streaming now. Oh, really? Well, I mean, usually when I want to raid, I usually search for like Zig, and I never find any. It's like sometimes, but most of the time I don't. I guess I've been unlucky as well. Okay, where's the floor? It's gonna be like one of these. Maybe this. That's a lot of bones and stuff. Here is maybe, this could be floor. Let's just pick one of these. I want to add like a way to add like variation and stuff as well, but for now we're just gonna pick one. 9266. All right, so now we've defined all of those things. Oh, this one is done. I'm just gonna send this off here. 2 to 3 compatibles fixed, blah, 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 blah. Okay, continue, please. You have to be nice to the AI sometimes. Is there a reference level, like a demo for this atlas? Wait, are you talking about this? So I downloaded this from itch. I can give you the link. It's an amazing tile map, according to me. Where is it? Here. Welcome back, Penguin. What is this Claude code vomit? Yeah, I'm being lazy in my, I'm making like a toy bash-like language. Where I built the base of the language eventually myself, you know, from scratch. And then I basically, when I wanted to add like a couple of features, I started to use AI. And then I just got into the habit. And now we're basically using AIs for so long. And it, you know, I had the experience where it actually was doing really bad. But then I kind of figure out sort of, you know, how to work with it better. So it's actually doing pretty good now. I don't mind it taking more tokens to get like a better result. You know, I mean, that's of course the best thing is to get a good result. But yeah, it's just for my like, it's not a serious project. It's just a bash-like language that will help me kind of not use bash, essentially. All right, anyway. Actually, what the hell? I'm actually lying here. Map border empty. We can just continue, I guess, as well. And not draw anything. Yeah, all right. Cool. Okay, so now we have to go to locations. And we have to add a new location. I'm gonna call this the dungeon. Yeah, it's a really awesome package or asset pack, yeah. And it's also like, what's good about it is so easy to add things. Well, I say easy, but you have to also be, you know, I guess since it's like pixel art, everything is monocolor, which is nice. And I added this kind of fireball thing. And I'm like, wait, this is actually pretty hard to make a tiny thing like this with monocolor and make it look like what you want it to be. So, like on one hand, there's not a lot of combinations, but on the other hand, it's like we still have to. So you think first that it's going to be easy to just add a bunch of things on your own, but then you realize that it's not as easy as you think, but it's still, you know, 12 by 12 tiles or sprites. So, you know, adding, like, if you get good at it, maybe that's why there's so many variations in here, then, you know, it's going to be pretty quick, I think, to add more things. And also potentially, since everything, like, it's monocolored, it's nice that it's colored in. Potentially you could grayscale this and print, like, tint it any color you want instead. But I like, you know, the visual of looking at the colors here. I mean, potentially, I guess you could grayscale it when you or grayscale. Maybe you can just turn everything white when you import it. You basically check, like, if it's a black, is it a solid color, then turn it white or something like that, and then you can turn it into any color you want. But then you would have to attach in code which color you want it to be, though. But yeah, anyway, then you can have a little bit of variation in the color and stuff like that if you want. But yeah, really cool package, and it gives you like a lot of inspiration. It also has like it like, at first I was looking at the screenshots, it looks like, you know, fantasy RPG. But then it has things like, you know, roads and guns and space theme, and it has like all different kinds of things. So it's like every time I look at it, I find something new, essentially. So that's pretty cool. Okay. So we need a new location, a dungeon, and we want to do things. All right. let's go to maybe overworld and copy this one. Okay. And let's see. We want to... Hang on, where is it? Oh, it's here. No. Where do we actually decide to generate something? I forget. Ah, here we go. So if we have a dungeon, we need to generate a dungeon. And the size... Maybe this is a little bit too much. Not sure. Maybe not. Sure. And then this would be dungeon setup, dungeon cleanup. Okay. And we don't really I guess we have like a location. Maybe we have like an exit location. We can say the problem is perhaps, do we actually have the generated map for us? So we generate. This gives us a location definition, right? And then we load this location, we get the definition, we generate a bunch of stuff, right? We call this function. It's a little bit convoluted here, I'm realizing. Then we have init scene, cleanup scene. All right, so we do have the map generated before we call the things. And this returns a location, which is then initialized. Okay, there we go. We found it. So at this stage, location has the map with everything in it. Okay. So the question is, where is this? Do we need to add like metadata to know where to put the exit? And I think the answer is probably yes. So here comes even more things. Okay, but maybe we don't really need an exit. We just need to find maybe like one non-solid spot, essentially. So I guess like to move the player. So if we go like map width, actually we could just go through the tiles essentially. And like if tile is solid, continue. Otherwise, we've found our spot, so then position will be well, let's do we need the player. Do we have player here? No, we have get by tag player, and we'll get the body. Didn't we have like move player or something? Oh, okay, it's like a function that we copy every time. Okay, I'll probably put that in some kind of utils place at some point, but whatever. Move player, so we'll move player to position. The position is, we have to actually get the index here. Let's just do this. So this would be like mod width. And we have to int cast I32. And then this would be over. All right. And we specify that we want to floor it. We don't need to get player. Okay, so as soon as we find a non-solid thing, we move the player there. All right, and then we break. Okay. And I guess we could also create a location back to overworld at that position as well. So let's actually store a position here. Yeah, let's do this. Position, and then we can use that out here. You know what you can do is you can say position equals this, and then you can break with position. Otherwise, if we didn't find a position, I'm gonna say unreachable, because it's like then the map did not have, I mean, we could do panic. Map did not have a non-solid position or tile. Right. Okay. So this uses like a thing that is sort of common in Zig, not super common, but I've never seen this in any other language. It's like you have a for loop that you can assign to, I mean, assigning something to a loop is not unheard of, but the else, it's what's I think is like pretty, if not unique to Zig. I don't dare say that is actually unique, but it's, you know, I've never seen a for else, but it's a pretty cool construct, and it kind of says that, okay, well, if you have a number of things you want to look at, and you have you have like the branch that does not find anything, you have the else of the for. So it's like you use the for loop to find here a position that is not solid. If we didn't find it, if like that means basically if the for loop was exhausted without breaking, is what this means. So if we didn't break out, it goes to the else branch. And yeah, it's very useful for things like this. If you want a constant, you know, variable assigned to the result of this expression here. So now that is that. Okay. And then once we have the position, we can move the player to the position. We can also spawn a location that goes to the overworld at that position. And the sprite, I guess, would be like a staircase. Upwards staircase. Do we have that? Oops. It's a neat construct. Yeah, I really like it actually. Upward staircase. Do we have that? Or maybe, yeah, we have this one here. Cool. 313.1. Of course we have an upward staircase. Okay. Yeah, so that's the setup. Create location should be exactly the same. There's no difference. There's just a utils function. Cleanup will destroy anything that has location key. Yes. Okay. So that means we could go into the dungeon. Now what we need is like from the overworld, how do we get to the dungeon? So we'll create a dungeon location at dungeon position and dungeon sprite there. Okay, so we need that dungeon position on the overworld and then a dungeon sprite. What is the dungeon sprite? I guess, is there like a dungeon sprite somewhere? It's like a cave entrance or something. Maybe this could work. Here we go. I mean, okay, let's do this one, I guess. It's like a tower. Cool. 3, 3, 9, 27. Okay, so we just have to decide where should it be. I'm gonna put it a little bit off to the right. Okay. Is it happening? Are we ready? Let's see if it compiles first. Is it gonna be a perfect dungeon generator? First try. Wow, it actually compiled. And here's the little dungeon. I need to fix the sprite. Okay. We have the room. Okay, maybe it's like a little bit too large of a room. Oh. Hang on. Okay. Dude. Why are they so bad at hitting? Oh my god. There we go. If it fails, it's time for Haskell. Okay, well, this looks weird. What the hell? Okay, I have a feeling. I mean, it kind of looks like a cave now. I have a feeling that there's something wrong with like the coordinate mappings. Okay. Right. Also, how dark is it for you guys? I mean, it did crash at least. Map. Donjon. Yeah, I mean, the dungeon. Is it dark for you? Because sometimes it's like when something is bright for me, it looks like, or everything looks like darker when you're watching it on stream or on a video or something. Okay, let's go through this. So number of rooms is, so room grid size. Oh, okay. Let's log out some stuff. Let's do some good old log debugging here. Room grid size. Room or tile grid size. No, we don't need that. We know what that is. Room grid size. And we could have like number of rooms, just to make sure that it like sounds plausible or reasonable, I should say. And the number of corridors. Okay. We could also log out like all the rooms being generated and stuff like that, but pretty dark. Okay. Like, can you see the difference between walls and floors here? Like this is a wall. All right. Room grid size is 12 by 12. That sounds reasonable since we have like 128 by 128 and each room is like 10 by 10 or something. Yeah. Number of rooms is 144 rooms. 264. I mean, the numbers seem correct. Yeah, 144 is 12 by 12. Corridors is 11, so it's 11 times 11, 121 times 2 plus 22. All right. Yeah. Okay. Okay, you can see. Okay, cool. Okay, but that seems correct. Maybe they are like overlapping or something. Oh, wait. Position is not correct. This is the grid position. This is not correct. We need to multiply by the size of the room or the cell size. Yeah. Okay. So I guess the rooms were positioned in room grid coordinates instead of... And there's always like a couple of stragglers. I need to fix that animation. Okay, here we go. Perhaps. The walls seem a little bit off. They kind of looks correct sometimes, maybe, but they do seem a little bit off. Okay. I mean, what we could do is maybe we'll add a little bit of padding, like the room cell size might not be like the actual size of the room. So maybe they could overlap. Maybe what we'll do is we'll say like this is the max size of the room is like room cell size, and then we take like negative some number. So max room size. Let's put this up here. Like max room size is room cell size minus oops. I don't know, like 2. That's the max size. All right. Oh, we have like room max size and room min size. There we go. I should remove this mage here. There we go. Okay. I guess a little bit better. Oh, wait. Why is the... It looks like the floor is like off-centered or something. Rooms. So position... Right, position... Yeah. They should also be... So we have the max room size, and then we should also have like padding. So the position shouldn't be... Or rather, I guess... Wait. Yeah. The offset should be like a minimum of 1, I think. Yeah. Okay. We reached unreachable code. Okay, let's do like max min offset so that they can be, so that max is never less than min, I guess. Okay, I think that obviously the floor is offset by, or it's either the walls are wrongly placed or the floor is wrongly placed. When we actually generate the tiles here. Yeah, it's the walls. This should be like -1. Yeah. -1. The right should be... Wait. Was the right correct? Maybe the right wasn't correct. Okay, let's do that. And then the bottom is also wrong. But let's do -1, -1, and... No, wait, that's the floor. Hang on. Here. -1, -1, and that bottom one. Okay. The floor was correct, I think. It's just that the walls were wrong. Okay, now we have a bunch of rooms. Well, I'm not sure what's happening here. It doesn't go like... And what happened there? Wait, why does it only go so far? Oh, it's the width. I did it. I did something. It resembles rooms a little bit more as we go. I'm constructing the rooms bit by bit, brick by brick. It's because I'm looking at the wrong size. Yeah, east and west. Here we go. It should look through Y, not like X. Okay. There we go. We have a bunch of rooms. Now let's do a corridor. One thing that I want to do actually is like the empty parts. Where did we put this? Empty. I'm gonna say empty solid. Because then we can't spawn there. Actually, what we can do is just do this. I need a better tile system, but whatever. Okay, so now we should be spawning inside one of the rooms, hopefully. Are you using any particular algorithm to generate a dungeon? Not really. Like I'm basically winging it. Whoa, what happened there? Oh, we went back to overworld, right? Yes, I forgot a thing actually. When we do cleanup, we also want to move the player back to the dungeon position. Right. Okay, I can explain kind of the algorithm here that I made. I basically just made it up. There we go. And you go back to the spot you came in, you get back up. And every time you enter, I guess we generate a new dungeon. Okay. So the way it works is right now. I just made a super simple testing thing here, algorithm essentially. But essentially it's like this. You get like a width and height predetermined. Right, these width and height or the tile cells. That's like in tiles. Each tile might be like this size here. And then I divide the whole grid, the tiles, up in room tiles or room cells. So the whole grid is like divided into larger cells. And in each room cell, I will spawn a room with a random size and a random like position within the cell. So each room has, or each cell here has a room spawned. Then I have a corridor, which I haven't painted yet. I have generated them, but I haven't painted them yet. The corridor is generated by first going through this first room, then adding a down and a right connection. And since, since this is a very simple construction, we know that, okay, well, down is just this cell, right is this cell. Okay. So if we go to the right, we generate this corridor here. what we do is we pick the east wall, one random point on this east wall, and then one random point on the west wall of this room. Now we have 2 points that we want to connect up, and we know that we can like safely sort of connect them up in any way kind of we want, as long as we, you know, move towards the point in like this. So basically what I do is I start here and I have like a step that goes to the right, and then at some I generate a point or an index along the line to where we should turn to meet the, you know, meet the position of this wall entrance. And then once we reach that, we move like, let's say the index is 10. So we move 10 steps to the right. Then we turn and we start to walk down here. And we want to walk down X number of steps depending on how far down this entrance is. And once we reach that point, now we go back to moving towards it again. That is the basic idea. And then I was thinking like, okay, well, this is a pretty simple thing. It does also cause these intersection could happen. If you have a case like this, you have a very long room and you have like another room up here. And then you have one entrance over here and one entrance over here, and they need to connect. So maybe it looks like this. And then you have one that this, and then they can overlap like this. But that doesn't really matter because the corridors are simply, well, I mean, I guess it could matter. But we could do the walls of we could do the walls first and then the floor of the corridors. So we could loop, I guess we could loop through them twice. First the walls and then the floors, because otherwise the walls would overwrite the floors of the other corridor. So that's what I have left now, actually, like painting the corridors. Which should be pretty straightforward, to be honest. Like, generate dungeon. Alright, so here we're going through each room. Now we want to go through each corridor. I think essentially what we just need to do is... Where do you go? Okay, you go there. We go through the corridors. We already have generated the corridors. Now I don't know if they're correctly generated, but I guess we'll find out. Okay, so we have the corridor. We have start, end, step, blah, blah, blah. So what we do is we have a cursor that starts out, well, let's just set it to the start position. So we have a cursor at the start position. And we say, let's just do board vector to index. So this would be a lot easier. We just say, basically, we have to int cast. And what do we int cast? We int cast x plus y. We also need a width. It's probably better if it's I32 and then times width. Okay. And so basically tiles cursor. Hello, Elita Locks, what's up? How's it going? So then you would be a dungeon floor. Okay. And this would be part of a loop. So we want to loop to corridor turn start index. and we say cursor plus equals step. So I set this up to be pretty simple to do at this stage, because we already have like all the convenient things. So we just step in the direction until we reach the turn. When we reach the turn, we want to go to end index. Right. Let's just set I equals j. It's kind of colored. Maybe we should have done, I don't know. But then we have to go j now, or I mean, to that. We get j here. And then I equals j again, I guess. I don't know if we need it. All right, and then, so now, and then here we do the turn step instead. So we do then, we're kind of rotating towards where we should go, and then do the turn step. Came to check out Zig because I heard Andrew prohibiting AI code, to be honest. Brave move if you ask me. I think it's good. I mean, you know, prohibiting AI from entering his, or, you know, the Zig compiler code, I think is a good thing. I mean, I don't think that AI is purely bad. Like, that's not my stance on it. But it's like, as long as you, like, take responsibility of the code that you're producing, like, if you're working, like, if it's on your own project, do whatever you want, you know? If you're working with other people, it's your code. It's still your code that you push up. Even if AI generated, it's still your code. You know, you have responsibility of the code that you use an AI to produce. So you will have to, like, you know, review the code that you're trying to push up, you know. But I feel like there's probably people that don't really do that. That are doing it lazily, which I think is easier to get into that idea, because it's you're thinking maybe that, you know, AI will just do everything for you. But I don't think that's good, because then you get like out of touch with the code, and when you want to implement something, you don't have a good idea of how to do it, and then you don't have a good prompt to give the AI either, to make it like AI is not that good that it can actually like manage a project that well. So it's like, if you want to add new features, it probably won't do it in a way that you thought, like how you would do it, you know, to make it like, I don't know, not paint yourself into a corner, you know, stuff like that. I'm also working on an open source project. I totally get what he did. I will had to review a few PRs that were currently generated by AI. It's always time. I don't think he's against AI. He's against AI wasting his time and steam. Right. Yeah, because it's not like it's automatically gonna make you more productive. It's like you're shifting the work to review the code that AI gives you, and also be able to prompt AI correctly. So it's like, yeah, sometimes it can go faster, but you're also like just shifting work around as well. And sometimes it's way faster just to do it yourself, and you're saving tokens, you know. But I get the you know, the premise. Since I use ADAS, Pascal, and Fortran, all AIs I tried are useless to me because training data was scarce for those languages. Okay. Are you like an oldie? Ada, Pascal, and Fortran. Like Ada, is Ada also like old language? I don't think I've ever seen Ada. Young 29, I only like old stuff. Okay. Well, that's cool. Ada 1983. Have you ever done any other languages, or are those the only ones you've looked at? What? There's a shadow? Where? Oh, this one, right. Well, we could... I mean, if there's a shadow, couldn't we just block this? Now there's no shadow, right? Uh-huh. Right, you want a width. The width is tiles. It's going to be width. All right. Okay, so we're going to the thing and then back down, and now we need to continue until like cursor is, well, if it's equal to this is not gonna work. Cursor not equal to corridor end position. So as long as it's not equal to end position, we will continue and we will move there. How much do you want to bet that we're gonna end up in an infinite loop here? Oh, you actually need an I32. Actually, you know what? Let's just accept an any type here. Any type, and then we'll do like as I32, no, yes, as I32 incast. So if it's an I32, it's already done. If it's a usize, whatever, it will work regardless of what you want to put in. Okay, cool. I did a lot of C2s and C++2, sadly. Okay. Nice. Yeah, I think it's good to get like a perspective. Because things that you learn in one language is, you know, like you can take like the accumulation of your learning several languages and apply it wherever you can. If the tool fits the job. Okay, so we have @reduce. @reduce, what is that? So that is an operation you can do on a vector. A vector in Zig is essentially just an array. It's like exactly an array, except it's like differently like compiled because it's vectorized. So it's gonna use SIMD whenever SIMD is a good fit. So basically this here is like an operation on vectors. Cursor is a vector of what, it's only 2 elements. So it's like an array of 2 numbers. And this is another array of 2 numbers. And you can, if they are vectors, you can do, there's like a special operator overload just for vectors in Zig. Like normally in Zig, you cannot define operator overloads, but for vectors, you can do like arithmetic and comparison, stuff like that. And if you do a comparison, then you get a new vector or array with a Boolean result instead of what it was before. So each component, like cursor x, was cursor x equal to end position x, then that becomes a Boolean. Was cursor y equals to end position y, that becomes a Boolean. So now you have 2 Booleans, and then reduce will, it's like fold. Like reduce is another kind of, standard word for fold. The fold operation is like you take every element, you apply an operation to get one, like a scalar result out. I should have said that to start with, but yeah, that's what it is. It's essentially just, you know, Haskell fold. Yeah. It's very specific to vectors in Zig. It's basically, and the reason is because it's like utilizing, you know, vectorization with like, you know, SIMD to make operations faster, essentially. Okay. It's the reducing function, yes. Or fold, as it's called in Haskell. Actually, in JavaScript, you have reduce as well. All right. Okay, so then we are done, I believe. Closure is reduce. Oh, I see. I see. I need some sound effects as well. Oh, there we go. Probably integer or out of bounds or something like that. Oh, integer overflow. Oh, because and the index was okay. So this is because this can happen if, you know, Zig, this is kind of weird because Zig has a bunch of these like checks for overflow and, you know, underflow. Like if you have uint and you take negative, it checks that it doesn't go over 0 and then it causes a panic instead of some other weird behavior. But it doesn't have a check for if you do a for loop and your starting number is higher than the ending number. If this is higher, then this will be like an infinite loop until we get the integer overflow. So this is a sign that this is lower than this. And even that this is lower than this then. So, yeah. Let's see, how is this calculated? We take that plus that. Oh, yeah. So we need to also take the start index plus that. Let's do it here then. Just because I don't want to have to deal with the casts. Okay. And then also, oh yeah, and then Haskell has, does Closure have anything that is equivalent to traverse? Because I believe traverse is like a more generic way to do a fold. It's like a monadic fold, essentially. And fold can be defined in terms of traverse, I guess. I never really done a lot of stuff with that, but index out of bounds. Okay. Right. So we didn't actually reach the end position. So this tells me this is like unaligned a little bit. Maybe we need to do like add one or something. Who knows? I don't think the closure is dynamic the types, it might not be needed. Oh, really? Oh yeah, because it compiles to JavaScript. Is that the only thing it's doing? Compiling to JavaScript? Integer does not fit in destination type. Is it going too far again? Maybe? Didn't you say that closure was compiled to JavaScript? Or did you, or maybe I read that wrong. Maybe you meant Java or something. I don't know. No, isn't that JVM and JavaScript? Okay, it has many backends. Okay. And soon LLVM. Okay. Const name type equals val. This one's interesting. If the how will you define them? Didn't see this in most other languages. It's like, well, it does. There, it's like exactly the same actually as TypeScript. TypeScript also has the same syntax of defining like a constant. You would see exactly the same. But of course, then you have like C would be this. And in fact, I think you have to have. Does C have auto? Or is that only C++? I don't know. But sometimes it's really nice to not have to put the type. Ada is name constant type value. Okay. Only C++. Okay. Okay. So we're a little bit unaligned here. I'm gonna check here. At this point, we're gonna assert that at least one of these is true. Okay. C has autokey, but compilers ignore since the 89 standard. They repurpose it so to behave like C++ in auto in 2023. Wait, they had it since 89? All right. So it didn't do that. Let's log out. This. Oh, oops. Let's log out end position and the cursor. Let's log out the turn start index, turn end index. And I also want like a step. Let's do everything. I mean, at this point, I could have just logged out the whole corridor. Step and turn step. Is it 1972 onwards autokey was used declare a variable that will be on the stack, which is default behavior now? Okay, but did you have to put the type there? Good morning, Evo. What's up, what's up? All right. Cool. So corridor start position is 7, 6, 12, 5. Start index 3 and index 4. So it should start at 7, 6, then move 3 to the right, and then 1 up. Yes, that makes sense. So it goes 3 to the right. Cursor is now at 10, 3. What? No, that does not make sense. So at this point, I should be 3. Wait. No, it's 2. And this goes from 2 to 4, 2 and 3. So actually, this is wrong. It should be like I plus 1. I think I needs to we need to add 1 here. Let's add. I mean, actually, we actually don't need to add the start index. We can just say, yeah, it's actually easier to do this. And then we don't even need I at all here. We don't need any of these. It's easier to just do this. You can also don't need to, because node C int was default type, didn't specify one. I mean, okay. But what if you assign it to a string or something like that? Okay. Yes, but okay, but what's the point in auto in that sense? What does auto actually do? Like what is the difference between auto, adding auto to that without or and not auto? Does zig not have the ability to print the context of a struct? It does have the ability to print the context of a struct. I was just beginning to say, I just want to look at one of the things. Okay, I didn't want to print the whole thing. But I can. You can do this. Corridor equals, and I think you have to put like any here. Maybe you don't. I'm not sure. But if you do it like this, that should also work. You can see how people realize that it's redundant occupies where it's smart to put the variables on the stack in all cases or to extract it out. Okay. Yeah, that still works. And then you get the corridor information here. So then it shows it like this. It shows it like an anonymous struct literal sort of here. You can also format it. Okay, let me show you how Zig works here with formatting. So if you, let's say you want to format it as a JSON. Well, Zig has a standard library, JSON format. you put in the value, and then you have like options if you want to have like white space, minified, or indent 2. But then you have to put F there because we want to use the formatting function. Now it's going to be formatted as a JSON. Because the standard JSON implementation can take any zig value essentially and output it as a JSON. Oh, it doesn't put new lines though. Wait. Oh, wait, it does put new lines. I put the wrong thing. I put the cursor as a JSON. It put it out as a JSON array. Okay, I wanted to put this as a JSON. All right. Why do I not remove this mage? I'm not sure. There we go. Okay, so now, yeah, this is like a JSON here. So there you go. Pretty simple. I actually really like how they did the printing in Zig. Essentially, this format function is very generic. It's like you can use it not only like when logging out things here. This is like a super generic pattern where you can use the same format function if you want to print things to a file, or you know, some like send a socket message or whatever you want to do. You can use this format because it works with like a writer interface. There's like a generic kind of, what do we say, a pattern like convention in Zig where you have a format function. The format function is determining how to format this type, essentially, which is really nice. And you can define it on your own structs to have them be formatted however you want them to be formatted. Have you ever played around with Odin? I guess you went with Zig for the comp time. I tried to kind of install it once and play around with it, but I think I met with some roadblock at some point. I don't remember exactly. I think it was the LSP. I got stuck with trying to make the LSP work or something like that. But yeah, I've never really went down on Odin, but yeah. Have you ever played... Wait, Jai looks interesting too. I'd love to get into the beta. Yeah, Jai looks very, very interesting. It also has like the comp time stuff, as far as I understand, which is really cool. And it has even better, it has like better like debugging with comp time, which I really, really would like to have for Zig as well. I think they should probably look at how Jai does it and just copy that when it comes to debugging stuff, because it's like, as far as I understand, Jai kind of shows you like the intermediate code generation, and you can like step through that code, or you can like inspect that the generated code. That is really nice. I would love to have that in Zig, because it's like you can do a whole bunch of cool comp time stuff, but it's like the actual code that gets generated would be so cool to actually see. I mean, I guess you can look at the assembly code, but yeah, you know. Anyway, okay, so the corridors seem to not crash now, but they also seem to not work properly. That sounds familiar. Expanding macros. I can show you a little bit of comp time here in a sec. Like how we can use it to basically generate code. Yeah, expanding macro. Yeah, exactly. So like if parallel to C is like, well, in C you can actually get the intermediate code from preprocessor if you compile with a flag. I'm pretty sure. But in Zig, I don't think there is a way to get the intermediate code. I haven't seen a flag at least for it. Maybe it's like hidden in some cache somewhere. But yeah. I mean, a very simple example of comp time in Zig. I'm not sure if that's what you were asking about. But I do have an example here. It's the stats. Yeah. This is well, a kind of simple example. So, well, here's an inline for. What is an inline for? An inline for is kind of like a code generation loop. It's like unrolling. You can unroll a loop. So essentially, if you have like inline for 0 to 4, whatever, and then we log out, you can even use this, you know, you can use this variable, whatever. This would get unrolled into, you know, this here. 0, 1, 2, 3. Oh, Lisp macro can expand. Okay. Cool. So, but this is how Zig works, essentially. You have an inline for, and you have a bunch of code in here that will automatically get unrolled, essentially, here into this. Okay? And then you can do a little bit more fancy stuff here. So basically, we go through each of the declarations of a type, which is this type here. The contents that you see in this file is essentially the type. So all of these are declarations, and these are all like components in my ECS system. So this goes, like every time I create a component, it's gonna end up in this file. So it's basically a list of all components. So basically this is how I can loop through all component types, and then I can get the component type out like this. And then I can do some comp time checking here to say, okay, do you have a method called whatever function name we want to put in here? If you have this method, then we get the component. This is the code that actually gets like generated here. This is the runtime code now. So the runtime code is like, okay, get this component from the entity and call the function that we know now exists, and we get some number out, and depending on the operation, we do like a sum or a product. And then in the end, we've gone through all the components that has this method on it, and then we like add the result. So essentially, it's like a stats gatherer. We're getting a stat from an entity. Let's say it's, you know, your player character. Your player character might have base attributes, equipment, like something in the inventory, an item or enchantment or buff or something like that. We go through all of those components that might be attached, and if they have this method name, this is going to get generated. So only the component types that has this method implemented will get generated here, essentially. So yeah, I really actually like how they did that. Now, I'm not sure if it's as powerful as Lisp, because people who talk about Lisp are like also a bit of a cult, I would say. but yeah, as far as I've seen at this point, maybe I've only met like maybe one or two. Anyway, let's see. There's something wrong with the corridors. The corridors are sort of working. and also they are sort of not working. It's like the start looks good, but also the rooms should probably not be this close. So I need to add more padding. But the start looks good. It goes down, and then it goes left. Now it should go down again. It doesn't go down again. Why is that? We drank the finest Kool-Aid. Yeah, some people swear by Lisp, but when I read Lisp code, it's like eList from Emacs, I only see a bunch of parentheses. Same here, man. You can't get past it. It's like a wall preventing you from being able to go, like, learn Lisp. Is there a Lisp version that works with, like, indentation-based scopes? Instead? That would be cool. You know, there was one for JavaScript, which was called CoffeeScript. I actually enjoyed that for a while, until there was basically no one using it, and you have to change the source code. Someone made one, can't remember the name. Okay. Precisely diagnose, I went deep on the integrated arg redirect deadlock with instruction level tracing, don't line fix, generate deep issue. Okay, so now you're saying, basically saying you've reached a point where you can't solve this issue. Interpolated argument into a file makes a deadlock. Well, that's not great. AI! Yeah. Unfortunately, AI is can't do this. That's bad. That's like the first time this has happened since the last time. Where I had to, like, rewrite the whole thing, because it had done some stupid stuff in the codebase. So, not great. Okay, let's postpone this for now. What other things was left for the task? All right. Anyway, let's continue. Where were we? Right, the generation. So it seems like it goes one way and turns, but then it never turns back. $114, cursor is 109. It should have kept going. Wait, 114, 109. Hang on. Isn't the turn step supposed to go down here? Or I mean, okay, wait. No. X stays the same. Turn index is 0, which means it never turns. How is it 114, 109? And then it stops. it goes like, oh, because we don't show where it's, okay. Where it ended up. Wait. It says turn step here. It should be step. Oh, okay. Oh, it's still not fully working here. Okay, let's look at one of the examples. This ended at 113, 110. Wait. No, this should be or, right? Because it's like... Or we do and equals not. It's like they have to be equal, but then we reverse it. So as long as it's not equal, we continue. Hello, Night Blaze. Welcome, welcome. There we go, I think. Look at this. Awesome. We have like corridors now. It even looks a lot like the old Rogue game where I believe like the corridors had like empty walls. I don't remember. Also, this goes down for a long time. Holy crap. Maybe it's a little bit too big of a dungeon. I did do it. It even gets these weird places here. It's kind of like a corridor merged with a room. Do we do like walls for the corridors now? It's nice when dungeon levels are bigger, more to explore and be afraid of. Yeah, I guess. We can try it. Okay, I want walls around the corridors. So this is the floor. What I want to do is I want to add another loop where we go through each corridor, because otherwise the crisscrossing corridors will kind of pave over or build walls over the other floors. So I want to build the walls. You know what? Let's build the walls. Let's build the walls before the rooms, actually. Is J even used here? I don't think so. We can move these outside of this scope. Okay, this is the dungeon rooms generation. And then this is the corridor. So let's put walls first of the corridors. Then we'll put the rooms, and then we'll put the corridor floors. Because they should like trump over the other ones. Okay. Okay, how do we do the walls? I mean, I guess we could just do like a 3x3 stamp, boom, 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 over each step. Paint. Radius. Dungeon floor. We also need like width. Maybe we need height as well, so we don't go outside. Actually, let's do tile grid size. And actually this would be a, this is like the size of the brush. Three by 3. How does it look? Let me show you. Okay, right now it looks like this. We have a dungeon here, and here is the dungeon. I think you right now you just start automatically at the top left. Also, why there should be stairs here. Actually, that's not true. You start at the first. It looks through. I guess it looks through each tile, like row by row, until it finds an empty, like an empty slot, and like a non-solid tile, and it puts you there. Yeah. Wonder if we could get like a crisscross example here. I'm not sure if we can. It's gonna be pretty random. All right. Let's see. So paint took, I think, let's do this, yeah. Oops. Tiles is tile. Grid size is board vector. Is it board vector or what is this? Yes, it is. Cursor is a board vector. Dungeon floor is a, I guess it's a tile. And then this is also a board vector. And it's, this is like the paint, the color, I guess. And this is the, actually this could be generic for any X, like any tile, or well, replace tile with anything else and it's going to be the same thing. This would be brush size. Are you using BSP3 to generate these? No. I'm pretty certain the answer to that question is no. I basically made my own very, very basic algorithm. So basically it's like this. You start out with a tile grid, which is not really seen here, but you can imagine this is like one tile up here. So imagine that this extends the whole thing. So you have a tile grid which has a width and a height that's predetermined. So that is like you have a predetermined size of, okay, you need to generate a dungeon that basically fits into this this size here. And then what I do is I divide the whole map into larger cells. So a larger kind of grid. These cells have like larger size, and these are the room cells. So they are evenly spaced out. Every room cell has to like the same size essentially, even though it looks kind of weird here. I draw it by hand. But then what we do is like I loop through all the room cells and I generate a random room in each cell with a random size and random like position within the cell. Okay, and then we have like, now we have one room for each cell. And then what I do is generate the corridors. And the corridor is simply, what we do is we go through first this room, and then we connect the bottom and the east, the south and the east to the next neighbor. And so if we take the east one, for example, we connect to this room here. So what we do is we pick one position randomly on the eastern wall of the first room. And then we pick one random position on the west wall of the second room. And now we have like the start and end position of the corridor. And then I pick a random point along this line here to say, now you should turn. Okay, so then we start by going towards the other room. At this point that we've determined randomly, we turn to walk towards the entrance. And once we've reached the entrance kind of level, we turn again to reach the entrance until we're actually at the entrance. That is how that works. So, and then the same thing for this, except we need to worry about like just, you know, if it's X or Y, which direction we're going and stuff like that. And so once that is all done, so then we go, so that's the first room. And then the second room, we simply do the same thing. We go to the east and to the south. East and south, east and south, east and south. Until we're here when we skip east because there's no east to go to. But we do the south. And then we like do the same thing here over and over again. When we're at the bottom one, we skip south because there's no south. We just do east, 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 east. And then this one doesn't connect to anything because now everything is connected at that point. And then once we have that, I basically gathered the information we need. So I basically have like all the room sizes, their offsets, and all the corridor start, end position, turn, you know, index, which direction they need to step and all that. And I'll be using that to kind of paint in the dungeon onto the kind of tiles that we have. And now I want to make a function that paints with like a arbitrary brush size, so we can yeah, so there we go. We have a cursor, that's where we want to actually paint, like that is the center. We have a thing, so only one room per big cell. What if to make the algorithm somewhat recursive, and after generate the map, you can take a random big cell and apply the same for a big cell to make several rooms in it? I mean, yeah, sure. I just wanted to make like a super basic thing to have something, you know. And I guess the next step would be to try to fill the rooms, like try to, you know, add monsters and stuff like that. But yeah, I can definitely look at different ways to generate rooms. But that's a good idea, like just recursively do it for one room. I guess, yeah, it would at some point the rooms would be so small that you would probably wanna do some type of minimum size check or something like that. But yeah, that is definitely possible to do it like that. Because then you would just remove the room that you made, turn it into a list of rooms based on the size of that room and the offset and stuff like that. Yeah. Okay, so paint. So I want the top left is going to be cursor minus the size. Let's see, how I guess it's just size over 2, like div floor. Because if it's 3, it's going to be 1, which makes sense. If it's 4, that doesn't really... It has to be odd, right? For us to be able to center it. And 5 would be 2, -2. Yeah, that makes sense. Okay, we have the top left. So actually, let's call this min, and then max is like... I mean, it's going to be the same. Except this is the extent, I guess. Okay. And then we'll loop through we'll do like min x, min y. I'll do like this. This is another way to convert or cast here, because I want this to be, I want these to be U size. Oops. All right, and then we'll go through min x to min y. Actually, it could be negative at this stage. So we're gonna do, you know what? Let's make these. No. Let's do like min or max, I mean. Max 0. Yeah. That's the only one we need to worry about, essentially. Well, actually, you know what? This one we can take min. You should be min the grid size -1. Yeah. Okay. And then we cast it. Now we can safely loop through. This is actually max x and then +1 because it's exclusive. Okay, and then y. Okay, what are we trying to do? We're trying to fill in the tiles. Well, essentially, this is just going to be like x plus y times... No, width. Except you're an I32, so we have to cast you to U size as int cast. Again, times the width. And now we can say tiles I equals tile. Isn't that it, essentially, right? Redeclaration of local constant max y. What? Oh. I'm just kidding. Oh, you're done. The clearest way to finish int go over the 3 small, less samples, normalize, but you leave it generate, sure. Do whatever you want. Man, I have to work ahead of me. God damn it. God damn you, AI. No, it's my own fault. Man, I can't wait to get to the innards of AI's project there that I've been running for a while now. Oh man. Yeah, that's, oh my god. Maybe I should just run like, hey, could you like improve the code quality for a bit or something like that? Like run on like maximum model or something. Could you just fix this code to be better? I don't know if you can do that. Div floor. I'm talking about an AI generated project, by the way, not this project here. Mixed scalar and vector operands. Yes. Oh, right. So you are a board vector. Choo-choo. Do you hear that, by the way? I don't think you hear that. There's someone operating on the walls. Okay, well, okay, I see what's happening. This should be wall. Also, we're only doing it here, and you shouldn't happen. So there we go. And then here as well. Should be like the same kind of idea there. Interesting. You don't. The mic doesn't pick that up. Do you hear like fans as well? Okay, there we go. Now we have the walls as well around the corridors. You can hear it. Do you hear the? It's someone is drilling into our concrete wall. Do you hear that? Now. Yeah, drill. Okay. Yeah. Yes, exactly. Okay, sorry about that. Because the volume meter showed like empty on OBS. Awesome. We have corridors. I'm not sure what happened here. Oh, I think I know. It's like this connects. It's too close to this room, so it does this. This is actually a corridor here, which goes into the wall of the room. I guess that's fine. But the walls seem a bit more cavey. They should be more like a dungeon. Let's see if we can find a better wall here. I mean these ones, but they're so dark though. Why so dark? I mean, like I kind of want this, but in this color. I mean, that's gonna be super easy to do. I mean, I will just take you, put you over here, and fill you in like that. And there we go. We've extended the tile set. Wait. This is the wrong one. Oh no. This is the one I should be. Okay, I'll just copy this. Put it over here. There we go. Okay, so now it's gonna be like this. I will... I guess I'll remove this because it's black anyways in the background. Actually, maybe it won't be. Because of how the floor, like if we paint over the floor, or the floor paints over the walls. Ah. We'll figure it out. Oh yeah, and then dungeon wall is gonna be this one. 105.27. Okay, now it should look maybe a little bit more dungeony, perhaps. Or maybe not. What the hell? Pretty sure I... No, I... Extract or export? Copy? Oh, wait. Okay, wait. No, that's right. We're using both. Oh my god, I can't believe I've done this. So I'm using both. It's because this version is not transparent. I should probably... okay. I'm gonna export this as well. So this is kind of like the tile set. All the tiles have black background, while the sprites are actually transparent. Okay. Now I remember how I did this here. Okay. There we go. I don't know. Does it feel more dungeony? I don't know. Okay. Well, anyway. Cool. We've got little dungeon rooms here. Now I guess we need to fill it up with like monsters and stuff. The question is, do we... I mean, we probably want to keep information about the rooms so that we could like properly generate the like things inside as well, because the generate map function only like the job is not to actually put things in the map. The job is just to make a like the actual tile map. It's not to like put things in. So what we want to do is probably also like save this information somehow, somewhere. The only thing we get here is like a bunch of tiles, and that's what we modify. But the location wants to have more information, I would say. The question is, how do we want to do this then? I mean, we could use, I guess, potentially the entity system. The locations right now, no, yeah, the locations are kind of stored in like a container that handles like loading and unloading locations. Oh yeah, also it like every time we enter, it's gonna generate a new dungeon. So maybe we also want to have a way to kind of cache the map once we have the location already. Well, actually, don't we already have that? No, we don't. We load the dungeon. Next time it's generated again. Yeah, we should definitely cache it, because we might have things that, like, yeah, persistence is not a thing right now. Persistence in the levels is not actually a thing. So I would have to think about that as well. I guess that's what's missing there. We need some kind of persistence stuff to work with this as well. All right. All right. I'm gonna refill my coffee. I'll be back in a minute, and we'll figure out what to do next. All right. Okay. I mean, I guess we have this function, the init scene. But then again, then we don't have like information about the rooms. So it's like the map kind of needs like some type of metadata, perhaps. And then depending on the type of thing, maybe we have different types of metadata, like we have, you know, the dungeon rooms. So let's do like union enum, and we'll do like, I don't know, we'll have none, and we'll have dungeon or whatever. All right, and here we have the rooms. We could even put the corridors in here. Corridors. Do you use conflict? No, we don't. Room corridors. I guess that's it. Okay. And generate dungeon. Let's put the metadata in here as well. Hang on a sec. All right, yeah, the cat was hungry. Did you hear that? It's like he had food out, but I guess maybe it was he always wants like fresh from the bag. Otherwise, it doesn't work. Okay. Right. So now, instead of freeing these things, we want to set you to be dungeon, rooms, and corridors. Okay, and now we have that data stored. Cool. And now we can use it in our location here to yeah, to do things. Find entrance position. All right. Not sure why this doesn't work, by the way. 3.13.1. I mean, it works. It's just it doesn't show the sprite. Hang on. Okay, I'm getting paranoid or something. It sounded like the cat was like choking or something. Okay, they're just messing around out there. Okay. This goes for transparent. Yes. But it should still be like visible. Okay, you know what? I'm just gonna open the door here. I think it just wants me to open the door. Yeah, why is that not like drawing? Because like we go in here, right? If I go back, we get out. Why is that? Because there's a location there that, or there's an entity there that says, hey, if you're on me, go to the overworld. And also I have a sprite that says upper stairs, or up staircase. Upwards staircase, but it doesn't show. 313.1. Did I put the wrong thing? It's this one. 313.1, right? Wait, what the hell? Wait, why are all these like the other way around? Hang on. Okay, that might be the issue. Okay. Let me copy this over. Not sure what happened there. Strange things are afoot. But we want to fill this in here anyway with an outline. I might be able to do this like we did with the text outline fix, which was pretty simple. We could kind of, I guess we could do the same with the sprites. It's just that everything needs to be drawn how many times more? 8 or something. 8 times more. So every sprite needs to be drawn 9 more times. Or I mean times 9. Yeah. Maybe we could do like a shader instead that kind of looks at the neighboring pixels. If there is like one neighboring pixel that is not transparent, it will fill in with black. Unless the current, if the current pixel is transparent, I guess, as well. From the texture. That should be pretty simple. There we go. Now I had a little stairs there. Cool. We want to do this one as well. Here. Maybe we'll do that shader today, actually. We have the CRT shader, but this one would be for basically all the sprites. Yeah. All right, cool. Now, I mean, what we could do is we could simply go through, let's just go through each room and spawn monsters. Let's just spawn the monsters. So we'll go through each room. I will spawn like one monster each room, I guess. Am I recording a macro? Map, method, I guess. Well, we know it's a dungeon, so for each room. So we have the position of the room, the size, so we can just take, like, min would be position, max would be position plus size, plus, and position would be int range at most, min, max, okay, that's the position. I should probably make like a vector random thing. Or make this work with vectors. This doesn't work with vectors, right? Do you work? No, I don't think this works with vectors. It assumes it's an integer. Okay. Actually, do we have like... we have random here? No, we don't. Okay, but this is the position. Now we want to spawn the monster there. So we have like... let's just import monsters. Monsters, create goblin, in position, the type. Now this could be random. Enum, which is goblin type. Okay, so now we should get like one random goblin per room. There we go. Also, I wanna balance these goblins a little bit. Archer, you are gonna have max health. Warrior has like 1, 2, 3. Let's say like 5 hits. 5 hit points. Archer should have like 2. Hello, iSense. What's up? Welcome. How's it going? And then Goblin Mage also has 2. Oh, I see. I-32. Cool. Oh yeah, their AI doesn't work either. Well, it works. Also, the mage spell doesn't actually deal any damage. So it just they're just there to stall you, essentially. Oh yeah. Also, there's no like line of sight checks or anything like that. You see, now it attacks me because it's like the AI is like you have to, because at first I made it so you can only move like left, right, up, down. Oh, there's a goblin in the wall. I can't hit it. Is there some shader? Picture looks like CRT. Yes, there's a CRT shader. Wait, I can't move. Did it crash? What happened? Okay. I think we reached some kind of infinite loop somewhere. Not sure where. Okay. There's a CRT shader. I took like one that I found, or like an algorithm or whatever, and then I've changed it a little bit. Because you can use, like, Raylib has support for shaders, but if you want them to work with like both desktop and WebGL, then you have to do a little bit tinkering to get that to work properly. But I've made it so that when I build, I can choose the target is either, well, it's either Windows or it's for WebGL or WASM. So that works pretty cool. Oh. Blah, 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 blah. Oh, thank you for the follow, iSense. Welcome, welcome. Starting with like complete their modules when they were done, based on the built-in design call. Let's do the pipe fix. What are we doing? Okay, let's fix some of these AI stuff. I mean, this AI is not going to be final or anything like that. It's just, I just want it to kind of work a little bit better from what it's not right now. So the the melee goblin doesn't aggro until you're right up in its face. It's like it just idles around. So the kind of the aggro distance is like one distance over. So maybe attack. So basically it only aggros if it can attack you, is what this essentially saying here. It doesn't check like, okay, is the distance less than whatever, or if it has line of sight. We could do maybe like a line of sight as well. Yeah, we don't have line of sight. I was wondering how to implement that, but essentially, since we have like a grid, we could just we draw a line. We see if we do basically like a ray cast. We see if we encounter a blocked thing. Okay, so what we could do is this: the line of sight algorithm. We have the grid here. Let's say we have a room, we have a person, and another person. Now, of course, we also have a grid. Of some capacity. There we go. So this is now cast over like this. So do they see each other? It depends if the things we pass through are going to be solid or not, right? So we construct a line or a vector between the things. Now we need to path or trace every tile that we encounter. So basically we start out at the starting point. So we're encountering this thing here. Is it solid? No. So now we go, the question is, which direction do we go? I guess we could calculate like a stepping function somehow. Like, what if step equals, and then we take the max of like the relative. So it's like if x is larger, I guess it would have to be the absolute. No, wait. Yeah, but anyway, if let's say we're talking about positive numbers, if that's more than whatever. So the thing is, like, I'm taking inspiration from the circle algorithm that I did before, where they were talking about, I don't remember what the thing was called now, but they were talking about oh, nice. Thank you for the link, Joseph. Oh, sorry for the flashbang. But basically, you would, if you know, like, let's say, because we knew that the direction was going to mostly go right, but then down. So basically, we'd look at this cell first, do we, so basically the algorithm is like looking at the current cell, does it intersect with the line? Okay. Then check the cell, is it solid? If it is solid, then we're blocked. If it's not solid, then continue. Then we increase, you know, we go one step ahead and we check, okay, are we still intersecting with the line? In that case, we check this tile. Okay, if we don't intersect, which is going to be the case, I guess, over here we still intersect, you can see a little bit, but over here we don't intersect. So then I guess we have to kind of backtrack or like move down. We backtrack, because in this case we need to backtrack actually. Do we always need to backtrack? I don't know. But anyway, we're checking here. And then here, and then here, and then we backtrack. Yeah, I guess it might always backtrack. So there we go. So then we checked like all of these things. Now, I'm not sure about the algorithm to check for a cell, like a rectangle intersecting with a line, if that is too complex. It's probably not that complex, but it's like, I don't know. Isn't that basically just to check? Well, no. Actually, yeah. So you could do like the BSP thing, where you kind of cut off the line at the end here. Because then you know that... Wait, no, can you do that? The core of the algorithm is what you can use, not the all render stuff. The functional way of doing it would be to collect all tiles, I guess. I think DDA is the simplest. What is DDA? Is that the one you sent me? Loads computer graphics tutorial raycasting. Table context basic idea on texture raycaster. Okay. Raycasting a render technique to create a 3D perspective 2D map. DDA is the core algorithm for the raycaster. Okay. Back when computers were slower, it wasn't possible to... I mean, I've actually implemented this where you take each line and you raycast it against a 2D wall. And then you paint the thing. Just skip to the DDA part. Okay. The DDA part. I mean here, the basic idea, blah, blah, blah. Map is a 2D square grid. Each square can be either 0, no wall, or positive value world. For example, every X of the screen. Send out an array that starts at the player location with a direction that depends on both the player's looking direction and the X location of the screen. Then let this array move forward into the map until it hits a map square that is a wall. If it hit the wall, calculate the distance of this. Use the distance to calculate how high this wall has to be drawn on the screen. The further away the wall, the smaller it is on the screen, and the closer, the higher it appears to be. These are all 2D calculations. This image shows a top-down overview of such rays that start at the player hit blue walls. Couldn't you have like a step that is a float? And you kind of floor it or something? I don't know. The DDA is about stepping through the cells. To find the first wall, you have to let it be placed all the time. Check whether the wall is not wall. Look and stop, calculate distance, draw a wall. Yeah. You have to trace it further, add a value. If the position is not a wall, you have to trace it further. Add a certain value to its position in the direction of the ray. And for this new position, check again. Couldn't you, like, potentially skip walls, though? A human can immediately see where the ray hits the wall, but it's impossible to find which square the ray hits immediately with a single formula. Because a computer can only check a finite number of positions of the ray. Many raycasters adds a constant value to the ray each step, but then there's a chance it might miss a wall. For example, with this red ray's position was checked at every red spot. As you can see, the rays go straight through the blue wall. But the computer didn't detect this because it only checked the positions with the red dots. The more positions you check, the smaller the chance the computer won't detect the wall, but the more calculations are needed. Here the step distance was halved, so we detect the ray went through a wall, though the position isn't completely correct. I mean, okay. But you could probably calculate, because you know which cell it was, right? Keep going. Okay. For infinite precision, this method, infinite small step sizes, infinite number of calculations will be needed. That's pretty bad. But luckily, there's a better method that requires only a few calculations, yet will detect every wall. Nice. The idea is to check every side of a wall where the ray will encounter. We give each square with 1, so each side of wall is an integer value, and the places between have a value after the point. Wait. So each side of a wall is an integer value, and places in between have a value after the point. Now step side isn't constant, it depends on the distance to the next side. The fractional part. Oh, okay, I see. Right. Okay, so now we stop at every integer, essentially. Like, yeah, this is what I was thinking, actually, when I said that we would floor it. But yeah, okay. So, but how would we calculate the other part? I guess we have like a velocity, or we have a direction. We have a slope, essentially, I guess. And we can, so the one of the components would be integer, while the other one is okay. Well, let's just keep going. As you can see the image above, the ray hits the wall exactly where we want it in the way presented in this tutorial. An algorithm is used that based on DDA, or digital differential analysis. I read this a long time ago, but didn't implement it one-to-one. It's a good article, though. Nice. Yeah. This is really cool here. Basically, as you step through each cell, you detect if it's empty or not. Stop at the first non-empty, declare no site. If you reach, yeah. That was my whole premise with the algorithm. It's just how to step through the cells. Digital differential analysis, DDA, is a fast algorithm typically used on square grids to find square line hits. For example, draw line on a screen, which is a grid of square pixels, so we can also use to define squares of the map or array hits, and stop the algorithm once a square that is a wall is hit. Some ray tracers work with Euclidean angles to represent. Okay. Now we make direction a vector as well. Direction is now determined by two values, x and y coordinate. Direction vector can be seen as false if you draw a line in the direction of the player looks through the position of the player. Every point on the line is the sum of the position of the player, multiple of the direction vector. The length of the direction vector doesn't matter, it's only direction. Multiplying x and y with the same value changes the length but keeps the same direction. This method with vectors also requires an extra vector, which is the camera plane vector. Okay, that's for rendering stuff. Okay, so, right, now the question is, how do you do this? I guess. Each side of a wall, integer value placed in between a value to point. Like, how do you know how? Yeah. We don't need that. The camera stuff. But now is the question: how do you know how far to go to get here? and then how far to go to get here, and so on. I mean, yes, it's an integer, but you would need to keep... So for example, here we go to x, you know, +1 from this cell, essentially. But what would y be? Scroll down more, skip rendering. Okay. That's just rotating stuff. Untextured raycaster. Start with the basics. Oh, I see. They're making this code now. I would recommend you skim the article because before stopping. Yeah, sounds good. I mean, I'm kind of going through the idea as well at the same time, so I don't like miss anything. And also, I might get to the answer before I read the whole thing. But yeah, start, direction, plane, time, old time. Okay. Screen. So we have array direction. Yeah. Okay. Here we go. When deriving delta dist x. And there's another link. In the next code piece, more variables declared and calculated. These have relevance to the DDA algorithm. Map x, map y represent the current square of the map we're in. The ray position itself is a floating point number, contains both info about which square with map we are and where in that square we are. But map x, map y are only the coordinates of the square. Makes sense. Okay, I'll look through this first here. Side dist x, thank you. Side dist x, side dist y are initial distance the array has to travel from its start to the first x side and the first y side. So side distance y, that's the scale that you have to go from a normalized vector, right? To get to the first thing. And then x, you go this. Okay. And then we have to calculate to the next x and to the, I guess, the next y. Aren't we skipping one? I guess they're showing it because it's overlapping here. Okay. Delta dist x and delta dist y are the distance the array has to travel to go from one x side to the next x side, or one y side to the next y side. Right. Hang on. I'm sorry for like stopping and stuff like that, but once you've reached this point, no, it's not always going to be the same distance, right? Because you're going to land on different things. Yeah. Wait, or... Hang on. To get to the next is going to be this, and then this. Shouldn't that be the same distance? Like this to this is the same as this to this, right? And then from this to this, from y to next y should be the same. Yeah, they should be the same distance. So you just need to calculate. Yeah, these are the only things you need. And once you have, so these are the first initial ones, and then these are the ones you would use again and again. Okay. So how do you calculate those? When deriving delta dist x geometrically, you get with Pythagoras the formulas below. Okay, I don't need to like understand. Okay, wait. I mean, yes, I know how to, if you have a right triangle, I know how to get the length. But let's just read through here so we don't miss anything. When deriving data this x mirror geometric, you get with Pythagoras the formula below. For the blue triangle, one side is length 1. That's true. And the other side is length radar y radar x, because it's exactly the amount of units the ray goes in the y direction when taking one step in the x direction. But is the radar, is that normalized? If you go in one, it's not normalized, right? It's set up. Wait, where do you explain this? It's dir x. What is dir x and dir y? It depends on the player, right? It doesn't really show how they're calculated. Ah, my brain. We'll figure it out. Wait, radar a. Oh no, it's a ratio. Radar y over x. Okay. One has length of 1, but would you flip this depending on... Right, this is for x. Okay. So x would be 1, yes, and then y would be the thing. Okay, and then you can calculate the distance, yes. So here's the length. Wait, what's this? Y squared over x squared. Okay, I guess I will trust this here. This can be simplified to absolute... where radar is the length of the vector radar x, radar y. Okay. So we take the length of radar and we take it over x over y. And we take the absolute of that. Okay. Yeah. Sure. I mean, I guess I understand. It's like, I don't think I need more for now. We can go ahead and try to start this here. What I'll do is, well, we could potentially, I could just make it here. Has line of sight. So we'll have like source and target. Big. We just need position. So source get well, actually, no, yeah, this is fine. Actually, no, what? No. We need to get the board position, actually. Wait. board position, yeah. Because that is like the updated position. And then target is target. Okay. However, they need to be offset by a half. Does it even matter? Yeah, it probably matters. So, but these are board vectors. We need to make them into, yeah, from int plus a half. I don't know, it feels better. Yeah. Okay. Now, right, so, I mean, yeah, and then we need like the direction. So basically, the relative would be source minus target, and then I'm pretty sure. So that's the relative. Now we kind of need to, I guess we need to kind of scale it down so that one of the components is 1. Because this is the direction. I guess technically we could just check what is gonna be, what is lower or something. Like if x is lower than y, we divide by x. No. Normalize. But that doesn't follow the documentation. I guess we can normalize it. Yeah. Let's do dir is normalize relative. I mean, because they kind of assume that one of the x or y is like 1, and the other one is not, is like larger. Like the smallest one is 1, and then the larger one is larger. So this here, 1, and then larger like this. So I basically need to scale in order to follow this here. But this, no, this is just a ratio, right? Couldn't we just set it? We just calculate the ratio and I just set. Yeah, I have the direction. This is the direction, but it's normalized. So what I want is, okay, I guess this is the normalized direction, and then we have radar, which is like the fancy thing. So what I'm thinking is this is just gonna be like, no. I'm thinking about the other thing, like delta dir or delta x is delta x is like y is 1, and then this, wait, yeah, hang on, but this is the, yeah. Y is 1, and then X is is it 1/0? No, this is like, yeah. Now we get the vector. How far we need to go to get to the next X, right? It's like Y is, no wait, this is, no, X is 1. And Y is Y/X. Yeah, delta this X is actually this scale, like this scalar here, that the length of this one. I'm just trying to define it as in terms of the components here, like so we get a vector instead. They kind of calculate the length of this. Well, I'm just trying to define the vector. So it's like X is 1 and Y is just yeah, Y/X, right? Which should be, it doesn't matter if we have a, what kind, actually we don't even need to normalize. We can just, because it's just a ratio, right? So it's going to be like this. And then delta Y is the other way around. And then you're going to be X/Y. And then we have to cover the cases, I guess. Cover cases where one of the rel components are 0. Whoops. So it's, I guess, like if this is 0, well, I guess we could put it here. Maybe if this is 0, then this should be, actually, I don't know. Okay, well, anyway. Side dist. Where did we talk about that? If radar X radar Y is 0, division through 0 is avoided by setting to a very high value. If you're using a blah, blah, blah. Infinity, which works correctly. Okay. Okay, I guess I could set it to infinity. Okay. Now, before the actual DDA can start, first step X, step Y, initial side is needed to be calculated. Yes, if the ray direction has negative X component, step X is -1. If the ray direction has a positive, is +1. If it's 0, doesn't matter since it'll be unused. Same goes for Y component. Okay. If the ray direction has a negative X component, side X Side distance x is the distance from the ray starting position to the first, side to the left. Otherwise, we would assign to the right. Same goes for the y component. For these values, the integer map x is used and the real position is subtracted from it. And 1 plus 0 is added in some of the cases if the side to the left or right of the top or the bottom is used. Then you get a perpendicular distance to this side. So multiply with delta x, this x, and delta this y to get the real Euclidean distance. Okay. I'm not sure if we need this, but I guess we'll find out. Side is x. Okay, they're just calculating this. Okay. And yeah. Now the actual DDA starts is a loop that increments the array with 1 square every time until a wall is hit. Each time it either jumps a square in the x direction with step x or a square in the y direction with step y. It always jumps 1 square at a time. If the array's direction would be the x direction, the loop would only have to jump a square in the x direction every time because the array will never change its y direction. If the array is a bit sloped in the y direction, then every so many jumps in the x direction, the array will have to jump 1 square in the y direction. If the array is exactly in the y direction, then it has to jump the x direction, etc. Yes, side dist x and side dist y will get incremented with delta dist x with every jump in their direction, and map x, map y will get incremented with step x, step y. Okay, I see. When the ray has hit a wall, the loop ends, and then we'll know whether an x or y side of the wall was hit in the variable side and what wall was hit with map x and map y. We don't know exactly when the wall was hit, blah, 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 blah. Okay. So if this is, so okay, it's looking for the one that's smaller, and then using that. Right. I guess the upside here, like using scalars, is you don't have to deal with 2 numbers. You're dealing with 1 number instead. I see. And then, but actually you are dealing with 2 numbers because map x. Okay, well, but I guess map x and map y, like what we could do is we could like calculate from the current cursor position is how I would think about this. This seems very, of course, optimized here, I guess. What is side? Side equals 0, side equals 1. It's just to know which side we want to show, I guess, if you want to render it. Right, okay. Okay. Cool. Let's see. Okay, so we need like, okay, what are the initial, like, side x is going to be, it was like delta x times, no, because delta x is not, No. Okay, we need actually the, I think, well, now we need the normalized, right? But side x is just, it's going to be dir times the distance to the next x wall, right? Yeah. So it's just going to be this x. Yeah, we can create this vector here, where x is like the position x in relative to this cell minus the start here. So then you get, no wait. We need this one. So it's going to be this minus this, right? So we get this. And then it's just, wait. Times delta dist x. Oh, because it's like, it's the same thing, except it's like scaled down, I guess. Okay. So we calculate maybe like, oh yeah, we can actually calculate what is the ratio. Actually, if this whole thing is 1, we just take this number and scale this vector by that, right? So it's going to be delta x scaled by source position x, and then I guess we have to mod 1. Does that work in Zig, by the way? Do you have a REPL? I don't think you do, no. Well, I mean, I guess it works for com time. Remainder division with F32 of com time int signed and just use rem or mod. Okay, I guess it works, right? You never know, you know. Yeah. Well, what happened to the precision there? How does it do this? I don't know. Anyway, it works. Couldn't you just remove the, what is it called? I don't know if it's the mantissa that is the, or is the base and mantissa. So if you just remove the base, couldn't you just do that? Like there's like truncate and stuff like that, but I would just wanna, I don't know. Anyway. So source position. Now this is going to be like relative to that cell. And then we take so source cell X. Actually, source cell is just going to be source, or source cell offset is going to be source position mod 1. Okay. And then we also need source cell, which is going to be like, no. Now we just take 1 minus that to get the scale, right? Yeah. And then this is just that scalar 2 with this. And then y is the same thing except for y and 1 there. I know I'm not following it like entirely. I'm just, I don't know. I'm playing around a little bit. Okay. So I guess now is like, I guess we'll do like while true. We'll check. I mean, technically, we could already be in a solid. So like, what is the tile? And this is where we need the map. Tile, get tile from cursor is source position. And I guess like if, yeah, if, do I have is solid here as well? No. If we're solid, then we can return false. If we're over here, return true. Okay, and now we need to increase the cursor based on, I guess, this logic here. Let me just go through this because I don't really understand. It's like, if, okay, let's start with here. If So basically what they're saying is that the one that has right, okay, I see. The one that has smaller, the one that has low, like the least length will get prioritized. So that one we do first. And then we'll do the next one, because this one has up to there. Then the length of to the next y is longer than the one to the next x. I see. That is also the magic of this a little bit. So then it goes, we add what's left here, we go up here. And now it's the y's turn. And now it's the y's turn again. And now it's the x turn. Okay. And that's why they want to have it as a length. Okay. So let's do like side x length is the length of side x. Side y. Whoops. And yeah, we still want to have a cursor. Sure, let's do it like that. And then essentially you want to check, okay, well, if side x length is less than side y length, that means we need to go in the x direction. So cursor is going to be plus equal to delta x. Delta x length. Delta x. Delta y length. Because I think we also then, we need to also increase this by length. Yeah. And then else it's gonna be delta y. Okay. So we terminate if we're in a solid. We can also terminate, I guess, if we reached our destination. Which our destination we can say here. No, actually. Destination. So target cell is gonna be div floor target position so if it's equal then we return true. target cell. And we don't need you. Well. Okay, I made it more complicated. I don't know. I went through, like, in my mind. It's just, I don't know. There's something about doing it like they do it, which is like, I don't know. And I tried to do it like, I don't know, using vectors and stuff, but it just turns out, okay, now we just have extra steps. And we have to do this check. Okay, but anyway, we need to cover the cases where we are exactly aligned on the, which can, I mean, that should happen very frequently because they are always like 1/2. Like there's not gonna be like a line of sight that goes from like 0.155 to something else. They are always at half position over a tile. So this should happen like all the time, essentially. So in this case, I guess what that would be like, we don't want to divide here. So what we want to do is, I guess we'll set, so if rel 0 is 0, if this is 0, we want this to be, I guess like 1 and then an infinity. We could move that. Hang on. No, we want this. Wait, is there like a safe? Okay, anyway, if it's 0, we will do something, otherwise we do that. We'll do infinite float 32. Yeah. Okay. Now there's also another way to be blocked, and that is by like dynamic objects. So but the thing is, then we have to iterate through all of the things, and it doesn't necessarily have to be blocking line of sight, I guess. It's just blocking like movement is what it. So I don't know. Okay, let's just deal with the tiles essentially here. I'm gonna add a to do here. Dynamic objects with line of sight blocking, question mark. All right, and that is essentially, we just create a component which like blocks line of sight. We will iterate through all of those components and see if any of them, I guess, like is in this cell, because we don't have like dynamic information in each cell where things are. I mean, I guess that would probably be a good thing, a good fit for this game, to just update like each cell with dynamic information like that. But anyway, it's not really necessary right now. Okay, so now we have this function. Let's see if it actually works. So let's go to like Goblin state machine. What I'm gonna do is I'm gonna go to draw, and there's like enable draw board state, which shows like if they have aggroed or not, essentially. So now, instead of just saying maybe attack, we set to aggro. I also want has line of sight context to some enemy. I guess this would be another thing. Later, like now we only have the player. Later we might have multiple targets that we can get, and then we would do maybe some kind of like, let's say we only check for things within a radius. So we would get all the tiles, all the cells within a radius, and just check whether any of those have any entities in them. I guess something like that, or something, I don't know. And then every entity within that radius we would check like has line of sight or something like that. But this would be the player here. Okay. If we have line of sight and is distance to player is less than or equal to, I don't know, aggro distance, which you don't have, but let's add that as well. 3. Then we're good. Let's actually, should I increase this a little bit? No. I'm getting issues with like the disk size is what that was. Okay, now we get actual errors here. Expected type. Oh, right. Entity. Is this also entity now? 267. All right. You. So you are a Victor 2. So this, I guess this would have to be a scalar then. Okay. We get a bunch of archers. Okay, let's let's just spawn a bunch of yeah, let's only make warriors. I guess I could add like logs as well. I'm getting to like, I have to wait for, oh, you know what? No, why would it take so long? Okay, well, obviously it doesn't work. Something is also lagging the whole game down. Maybe, okay, maybe we'll do this. We'll go to town and we'll add a monster at player position plus, wait, no, +1. I just want to see where it is. So presumably the line of sight probably returns false. Yeah, some debug drawing, yeah. So let's do like this. Okay, let's do it like this. When we create this thing. Okay, I'm gonna do it like this. We're gonna have a debug, raycast debug information. It is going to have I'm gonna have like traversal. It's gonna have a list of vectors that we traversed through. I guess easiest would be to make this just an array list. And is that it? Then we could also store all this information here, I guess, as well. But let's start there, because then we could kind of show that. So then over here, we would say like traversal or raycast and then raycast debug, we will traversal, we will append wait, don't we have game here? Oh, we have that. Whoops. And then this would be like cursor. I guess we could like add it here, I guess. Okay. And then what we'll do is we will say if we have singletons try, no, there's no try here. I guess if we have a raycast debug, I'm going to get it. And I guess we'll like free it. Now let's just traversal deinitialize. Yeah. Okay. Otherwise, I want to add a singleton, and I want to add this raycast debugger. Okay, now the rest of the game should like have this information, and so we can go to draw, and we'll draw gameplay board state. So here we can say if we have now this is like import wait, where were we? Monsters, raycast debug. Okay, if we have this, we will get it. Okay, and then we'll kind of, we could probably like show the traversal. So basically we could show like okay, actually one thing that I want to do first is only look at distance first, so we shortcut that, because otherwise everyone will check line of sight. This is better anyway. Oh wait, did I never set what to do there? Okay, well, so it might have worked, but yeah, we'll check the distance first. If the distance is like outside of the aggro distance, we don't really need to check the line of sight anyway. Depends on which one is like more costly. This is probably more costly, yeah, by far. Yes. And then draw, so we'll get this. Oh yeah, I wanted to add like, let's do like current index and next index at. All right. And then we'll do like duration. So basically what I want here is it's gonna animate how it stepped through, right? So we're gonna say like for raycast 0 to index. Now this is real time. This is gonna be real time, not simulated time. plus duration. Okay. And then like if raycast debug next index x is less than or equal to lapse real time, then we will set you also to be that, and then we also increase index, but we also mod equal to traversal items length, so we don't overstep. Okay. Now, I guess we go to index. Do we go to index +1, I think? Yeah. So now we can draw this thing. We'll go, we have the traversal, we have index. This is now the step that we took, or the cell that we're looking at. It's an F32. We can, so this is like the float version. We can turn it into an int version, or wait, no, to int. Do you do anything? No, you don't. But we can floor it as well. Okay. It was the cursor. The cursor is... It's not pixels. It's in cell coordinates. It's just that it's a float. So we don't need to divide or anything like that. Okay, so now we have the cell. So we can make it into a rectangle by saying... well, actually, we have the... this is like position or cursor, whatever, right? So we can both like draw the cell that it happened in, and then we can also draw the cursor as well, where it is. So like draw circle or something. Center is cursor to raylib, because you are a float. Yes. Radius, I don't know, maybe 2 or 3 or something. Color, something there. Okay. So now we're gonna show that. I guess we could also show the line. It doesn't matter that much, I guess. The cell, we can draw a rectangle. Position would be cell times... Wait, why do we need to put this there? We probably don't need to do that. We just floor it and that's it. And then we do like... Cell top left is like cell times tile size normal. This would be cell top left. This would be tile size normal. And then the color is, we could do like alpha red 0.4 or something. Okay. So that will show us the raycast that we're currently doing. Does not support indexing. Oh, items. There we go. All right, game to raylib. Same thing here. So we go down. Okay, well, it did aggro. But we're not seeing anything. So we add the thing, we add the thing. Oh, because we just return through. Okay. So we have to defer. We can defer all this, actually. No. That has to exist, but we defer this. Okay. Because otherwise it returns and we don't see anything. What? So the cursor starts out. Oh. It starts at source position. That is not. Well, it is correct. Yeah, it is correct. Because this is not pixels. This is board position. Yeah. So that is correct. Huh. Let's get some information here. Interesting. Something only happens when we're like straight ahead. That was strange. That tells me this distance thing does not work properly. For some reason. Get offset to player. Yes. And then length. Okay, well let's look at these things. Source and target. Okay, target cell. That is not correct. What the hell? Oh, I divide by this when I shouldn't, because this is already in cell, like tile coordinates. So essentially it's just going to be target position, I guess like floor, like just floor, not div, just floor it. There we go. Okay. Okay. It's going it's going somewhere. Source position, yeah, you need to go. Okay, this looks a lot better now. I mean, I guess we already kind of have it with. Yeah, we already we already had that with this thing here. This is the actual target cell, and then the position is just +half. Okay. Yeah, and then relative is 3. That's not correct, right? It should be -3. No, it is. No, it's not correct. It should be -3. This always trips me up. I can't believe I do that every time. It still goes to the right. But now relative is correct, right? Because the source is larger than the target, so we need to go -3. Target minus source, yes. I always get that wrong. It's like, I don't know how I do it. Okay, and then delta x is like 1. This does not seem correct. Well, actually it seems oh, I know. Let's do like times the sine of rel 0. I hard coded it to 1, so it couldn't go to the left, I guess. There we go. Boom. And you should stop there. Okay. It keeps going for some reason. Until, I don't know why it stops eventually. But okay. Why does it go so far? 31. The cursor stopped at the player though. Or did it? No, that's where it started, right. It started at 3117. Delta x. Yeah, offset 5.5, that makes sense. Side x 0.5 makes sense. Length is 0.5 makes sense. Infinite makes sense. cursor. Okay, so everything here makes sense, but why does it keep going? So there's no stopping it. We check if it's solid, or we check if we reach the cell. Oh, it's the same issue here. We don't divide, we just floor. Right. Boom. There we go. I see you. Okay, cool. But now the question is like, why is it not seeing me when I'm... Okay, and here you can see an issue. Something is very wrong here. It goes like back and forth. That was I guess was what was lagging before. So what did you do? Now we have like both X and Y are different. Target cell, yeah. Relative is -2, -2. So delta X goes left and up 1. I guess that makes sense. Or does it make sense? Shouldn't it be -1 and then a half? Or actually negative, it should be -half. Because X goes -1. Wait, hang on. No. It's from the start, right? Because then both would be half. So side X is -1, -half. This is the issue here. The sign of this is wrong. So it should also be times the sign. Do you work with vectors? Vectors of integers and float types. Okay. So then we can do like times the sign of rel, actually. It's drawing an M, an okay. -1 with -2, -1, -2, half. Why is this? Why is that 1 and not -1? Oh, it did it twice. Okay. And now it's skipping ahead. What the hell? Target cell. Seems fine. Side X. That seems correct. Side Y seems correct as well. Okay. X. Oh, because the first time, no. You know what? I think the issue is we're relying on this floor stuff. I'm just gonna do like they do it and just have like map X, map a Y, whatever. Fine. Map. I'm gonna have like map cursor is like source position floor. This should be safe because it's just like 0.5, right? And then we do like 2 integer. All right. And then we can do map X step, I guess. Let's do map step is like, what is that? Like relative. It's gonna be like sign of relative. Okay. Sign of relative. And then let's also make you into an integer. All right. And then over here, instead of dealing with the cursor, we're gonna say map cursor 0 plus equal to map step 0. And so on. Cursor doesn't exist. And let's add map cursor. But now we don't see the position. I guess, yeah, whatever. That wasn't. So this is now a board vector, and here we'll get this, which is a board vector now. So that is the same as that. You yeah, there we go. Okay. Get tile. No, wait, this is wrong. Okay, let's do like this. Tiles, map cursor 0 plus map cursor 1 times width. Int cast as vector to usize map cursor mx my. Map cursor equals target cell. Are you used for anything else? No, you don't. So we can do 2int I32. Make it into a board vector. Wait. Do you change the type? Oh. You're changing the type to an integer. Okay. Okay. I guess we'll do as vector I30. Well, actually we could do like board vector. You know what? Board vector like this. And then we do int cast instead. There we go. Boop, boop, boom. Great. And then and now it's not even checking because it's already aggroed me. And well, I mean, I guess it makes sense that it would check those tiles. Interesting. Because it's right on the edge. So it's like you would, because it goes from the center of the tile to the center of another tile. If we're like exactly 45 degrees, you would expect to only check these tiles, right? Because now it's like if these 4 are open and we have a wall here, that blocks the line of sight. I mean, I guess it could. It might look maybe a little bit weird here. But yeah, that's interesting. See if, yeah, that's the same scenario. If I move over there, yeah, I mean it seems to work. So that's cool. Awesome. Cool. Yeah. And I mean, I guess technically we don't need to do this if okay. Boom, boom, boom. Right, you have aggro. Okay, cool. Now I guess the next step would be to check, you know, line of sight within, you know, from here. So let's say it was spawned over here. Let's add like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 maybe. And then 10, negative 10y, 3, and 3x. Negative 10y, 3x, negative 10y, 3x, negative 10y, 3x. See if it works. So now it shouldn't like try to, well, we should see the result of the raycast as well. It tries to like, see? And there should get blocked and not actually aggro. Cool. Same thing here. It gets blocked. And over here it gets blocked. Cool. And here you could argue maybe it should see me, right? It's like right over here. I'm not sure how to deal with that. Also, if I attack, it should like automatically aggro if I do damage to it. But cool, we have kind of the basic thing working there, so that's really cool. Let's could put this in an actual like function. like has line of sight you know what, we could just build it in here. We could have like a range. Actually, let's just build it into this function. So we get like source position, we have the relative. Let's do if the length of relative is less than or equal to range, or I mean if it's more than range, then we return false. So now instead of, we don't have to have that in here, we simply say aggro distance is the range, and there we go. And now we can say that here as well. Except attack kind of implies now that we actually have distance, but we also need, let's do line of sight instead. Context to get player. And aggro distance. Okay, and then same for the mesh. All right. Cool. So now all of the goblins will have line of sight stuff. So let's go to dungeon. Now we'll go back to random goblins. And let's go and do some dungeoneering. You saw me. Okay. Cool. Maybe, okay, another thing, because I feel it now when I move, is like things stop for a second and I feel like I can't really do anything. Maybe we'll do like this. If we deem an animation be like happen like outside, kind of like, I'm not sure if you've played Civ, like Civilization, like the first Civilization. There's probably in the other civilizations as well, but I distinctly remember like the first Civilization, you move around on like a grid style map like this one, with your units, and the enemies, the AI would move around theirs, but like, and they would be all over the world, right? So you would have enemies like all over the world moving all their pieces, but if you didn't see them, it kind of skipped over showing like animations for it. So that is kind of what I want to go for here as well. It's like if we can't see the goblins actually move, you're kind of stuck and you're left wondering, why can't I move here? Also, it probably makes sense to not show the animation if it doesn't like cross over to the screen. Yeah, because yeah, why would you need to show that? It doesn't even, you can't even see it. So yeah. Also, the melee goblins, they can't actually move. Okay, here's, maybe we can get this guy to kind of try to see me. I mean, I kind of already know it works, so whatever. Question is, like these archers, they basically always hit you. And that guy was actually, did not get his turn in. Yeah. It's just that I'm not sure how we could determine. Hey, thank you, Piano. How we can determine if like an animation is like outside. It kind of depends on like if you play the animation out and you look at all the different things that are supposed to get spawned. It's almost like you want to run the animation in a simulation first to see if anything intersects with the screen or something like that. Before we, or we just determine like, okay, well, if things are like outside the screen at a certain distance, maybe we don't even show what's happening. I'm not sure. Okay, cool. What to do now? There's so many things we could do. But yeah, we have a basic dungeon generator. We're spawning enemies. We are generating a map. We have the location. Now what I want to add is random chests. Now we don't have like any items, and there's no way to kind of, I guess, equip an item either, unless we just say that if you move onto an item, you equip it for now. Because we don't have any UI. There's no UI for like equipping an item or looking at your inventory or anything like that. Right now. I have no idea how that will even work right now. But we could like have chests, or we can have monsters drop random stuff as well. I guess we'll start with making actual items. Like right now, there's no item things at in any capacity. We just have these things. I guess what we could do is we could have like an item component that potentially can be equipped. I mean, an item doesn't have to be equipped. We could, I mean, we could do like component equipped, and that is, it can get, I already, like the equipment is already a thing here. Equipped can be a component that says that, hey, this item is supposed to be able to be equipped, and then the slot is like one of these slots here. Mobs should drop secret chest keys. It will be a very cool future or experience maybe for leveling up. Yeah. There's gonna be all that kind of stuff. One step at a time. It's pretty cool because each thing you add will like add to the entire experience. But it should also be, of course, it should be balanced and stuff. But I just wanna, because I haven't worked out exactly how things will, like how you will control everything, like how do you equip. I know that I want it to be like this classic, you know, roguelike game, but I'm not exactly sure how everything's gonna play out. Yeah, maybe we'll create a component equipped, because otherwise we would have to kind of, I think another way would be to create like one component for each body type that it could equip to, I guess. That could, I mean, that could be a thing as well. But it would be maybe a little bit annoying. Let's just have this component equipped. This would be for items that can be equipped. And then we have like a slot, which is going to be the slot where it's going to be one of these, essentially. So a slot is essentially going to be like one of the fields in equipment. So it's like a field enum of equipment. Okay. Actually, let's have this enum be here. Equip slot, equipment slot, equip slot. Okay. And I guess that's basically it. It just describes that this can be equipped. I'm too impatient. Yeah, same here. You have to have a little. That's the thing about game development as well. It's like you have to have a little bit of patience, because otherwise you're gonna get frustrated that it's going too slow. Things take time, and you have to let it take time. Just meditate. I guess that's it, maybe? And then, you know, we can have things like, okay, well, an item gives you a bonus to this, gives you a bonus to that. Maybe it gives a bonus to defense value. Yeah, so for example, I can create a component that gives me a damage bonus, for example, which could be for like a weapon, for example. We can have different weapon types, like a weapon type. Let's do like melee damage bonus, maybe. It's just going to be a component that whatever this is added to gives you a melee damage bonus. And most importantly, we have to implement the function melee damage bonus, because otherwise this won't get picked up by the attribute system or the stats system. So you have to have this function, which takes self, returns a U size, and then we return. Oh, actually, it's an I32. That's right. It's an I32. And then we return, because technically you could have negative as well. We should allow that. And okay, so now we have that. Now, how do we create the items? I mean, that would be, for example, if you go to monsters, maybe we should make a new thing called like items or something, which like is whose responsibility is to like generate items, I guess. I could just have an item here, essentially. Or actually, no. What I need is a function that gives us a, I don't know, let's just do like a sword here. Let's do like a bronze sword. And this gives us an entity, and this will need game. And I guess position as well. All right. So we'll do game and create entity. And body, position, size, options, and guess renderable. The sword. Right. So where is the, how does the sword look like? Here's a bunch of swords. Let's just pick this one. That one is, well, first of all, I want to outline it, because otherwise you will barely be able to see it. Okay. Are the mobs and items in the same category entities? Yes, everything is an entity, essentially, in the ECS. Okay, where is this? This is at 33979. Okay, we should probably, yeah, also have like a board position as well. Actually, this is the board position. I think my cat is dreaming or something. Board, math, no. I thought I had like a way to, I mean, it's just gonna be board position times normal. Yeah. And then you are the board position, right? Debug color, I don't know, blue. Yeah. Oh, plus a half. I really should have a convenience function for that. Okay. So we have body, board position, renderable. So it's an equipable. So let's do like equipped. I guess this doesn't really make sense. Well, let's just do left hand, whatever. Usually the sword is in left hand, right? And then we have, and then now we can add like damage. Oh my god, why did I really do that? Yes, I did. Okay. Melee damage bonus. 1, let's say. My generation function no kebab cannot handle if I pass in Pascal case, it actually doesn't work. All right. What happens now? Now we are doing stuff. Okay. What's happening? Okay. I guess we'll return this as well. So now we have a way to kind of create a bronze sword item. So let's go to the monsters. Now we can like use that. I'm just gonna also add it here. Let's call this item maybe. Okay. All right, piano. Good luck yourself. Take care. Okay, so when the goblin dies, maybe we should have like a loot component. Let's just do this. I mean, I could easily just add it, loot, or drop on death or something like that, like loot table component. And then we just add loot table here. Wait. Where is it? Yeah. And so the loot table. So basically, yeah, somehow this will produce some type of item when you die. So like we could have, for example, oh, thank you, Christoph. Welcome, welcome. Raid with 79 viewers. Thank you, thank you. How did your raid go? All right, raid and run. Thank you, thank you. Welcome, everyone. Thank you, Nicola, for following. Nicola or Christoph. Thank you, thank you. All right. Cool. Followers goal as well. Nice. Thank you, everyone. All right. We're doing... and I'm working on the invite tree implementation for Radical. Going well. I'm working on a fuzz testing architect infrastructure. Oh, nice. I don't know what Radical is, but sounds cool. Cool. We're doing a retro style RPG here. See if I can get it to run here. Yep. So it's like very early here, but it's like we have basic map generation. Here, over here is a dungeon. We just did this today, this dungeon generator here. And you have a bunch of like goblins. I have some debug information here. But yeah, a bunch of goblins populating this dungeon down here. I should remove this stuff. And now I'm working on adding the first items and stuff in the game. Hello, hello. How are you, everyone? Was the stream good, or did it go well? Let's see. Oh yeah, draw. Let's disable this. Okay, loot table. So I want a function essentially just saying, what do we drop? Get drops or something. I don't know. Generate drops. And I guess, do we want like this? We probably want the source that like has the loot table. Then we don't need game actually. Yeah, I guess that's what we need. Cool. All right, so let's just say, and we need self, of course. And CRT, nice classic. Yeah. You have to have the CRT. Once you go back to a certain retro style, the CRT fits really well. I would say. A certain pastiche, yes. I don't know what that means, but yes, that sounds correct. Okay, so let's just do like, if we have a chance of like, I don't know, 50% to drop a item bronze sword at our position. Actually, I need the board position. Yeah. Context, get. Oh, thank you. Same Timri. Thank you for the follow. I'm pretty sure I never pronounce anything correctly here, but yeah, sorry about that. But thank you. Welcome. Okay, so we want to get the board position component, and I think this gives us the thing. It's interesting, like the LSP doesn't really give me any information about this one, but it knows that somehow this position is a vector too, blah blah blah. Greetings, how's it going? It's going good. That's very retro style. That looks like a font that would actually fit in this game here. Like a Castlevania Gothic type font. Right. Well, I guess we don't care. All right. So everything can every goblin now has like a way to Okay. You type really fast. You must be used to it from your job. I mean, yeah, I've been programming since I was a wee child, essentially. You know, I was a nerd. I've been a nerd all my life. I mean, I think that everyone nowadays are pretty good at typing fast, but back then, you know, the parents and older people was maybe the only ones that were slow, essentially. I'm not sure if I'm discriminating against you now, but sorry about that. Generate drops. Yes. Okay, now we need to call this function whenever we die. I could create a loot system or something like that, I guess. Sure. Loot. All right, so we need to go through everything that has essentially like loot, table, and dead components. We could also have like a marker if it has dropped the stuff or not. Because this is going to happen. This is going to happen every frame until the animations are done. Oh my god, are you randomizing your fonts? So as a developer, what do you think about AI reaching this level? Claude anti-gravity agents? I think it's cool, actually. Whoops. I mean, the thing is, like, I don't mind using AI. Like, I don't have like an inherent thing against it. It's like a tool as everything else. But you know, as I said before, the thing, like if you're working together with other people in a company, for example, you're working together, you still have like the responsibility of like the code that you're producing. So however you produced your code, you know, you could be copying from Stack Overflow, or you could be generating from AI, blah blah blah, whatever you do, you have the responsibility of that code being up to standards with your project requirements, and not piss off a bunch of coworkers that's constantly getting like bad code from you. I mean, that goes for you if you're using AI or not. Like, you should always try to improve and make better code, essentially, and learn from mistakes and stuff like that. So that is kind of my take. Like, but it's especially important if you generate code, you have to kind of go through it to see if, you know, how it looks. I know that I think some programmers use AI as a way to kind of skip, like, think that it's gonna solve all their problems, but that's not the case, because you're essentially, what you're doing is you're just shifting the work over to different like you're doing a different kind of work instead of actually programming. You have to kind of review the code, and then also become a productive like prompt engineer, essentially. So there's like other types of work that you have to do now. And sometimes it can be productive to use AI, and sometimes it actually hampers productive, because it generates a bunch of shit that, you know, and then you're like, okay, now we wasted all these tokens, we wasted all this time on this stuff, and it's better if we just write it ourselves or something like that. So it's like, it can giveth and it can taketh. But, and also is the question, like, what if AI becomes so good that in the end we don't need programmers anymore? That's gonna totally change the whole landscape. Like that's so. It's like if AI can get so good that we don't need programmers anymore, then yeah, all you're gonna have is a bunch of AI prompt engineers essentially. I think it's gonna be like that. We're gonna lose the kind of knowledge about programming, and it's just gonna be AI doing everything. But I think, I mean, I don't know if we're ever gonna get there, or if we're, you know, how far off into the future that's gonna be. But that could be a future. But of course, you know, you can still program for fun. You know, you don't have to delegate everything to AI. Speaking of, I have this parallel thing here where AI is doing stuff. Okay. You know what? This requires me a little bit of thinking and reading, so I won't go through this right now. Actually, what is your decision? One, yeah, I need to make some input here apparently to this AI. Man, these interns, they can't do anything themselves. Would be a sad future. Yeah, but it's possible. It's like, yeah, because no one would need programmers anymore. I guess it also, maybe it depends also on, like, you know, how much energy is needed. Like if we can solve the energy problem, there's not going to be any hindrance except for, I guess, mathematical limits to how good AI can be. Vibe coding is a new term. I don't think it will put an end to professions. I believe professions are evolving and new terms are emerging. Yeah, but that's what I'm saying. Like instead of like programming normally, you would be a prompt engineer. In 20 to 30 years, there will be new professions. People will look at the stranger first, but life will go on. People will get used to this and that quickly. Yeah, I mean, it's the same. It's like the Industrial Revolution and all that over again. It's like these like jobs disappearing and things like that. But for now, that's not the reality. And maybe it never will be a reality. We'll see. Who knows? Probably will, but we'll see. I mean, I'm saying probably will because of the rate of AI has been going at this point. Like it went crazy first when ChatGPT came along, and then, but it still couldn't code. But then it could start to code a little bit, but then it kind of tapered off a little bit. But then it's like just exploded, and all of a sudden now everyone is using AI to generate code. And it, I guess, yeah, the agentic thing is like it's getting like better and better and all that stuff. Okay, what are we doing here? I need to put like, well, let's just put here is like, I guess we could do enabled. We could just set enable to false. Loot table equals this get the loot table. If the loot table is not enabled, we don't care. Actually, you know what? We could just remove the component altogether instead. That seems better actually. Okay, but we get the loot table. We will call generate drops, and we will remove the thing. The thing is, we cannot remove it afterward. Actually, we just remove everything in this iterator. Is there a thing for that? I don't think so. Do I have to like copy? Okay. So we'll do an array list of entities. We will set you to empty. We'll go through the list of items and we'll remove the loot table, and there we go. And here we will append to this. Okay. Okay, so there we go. And then in update, we will bring this in somewhere. Where should this happen? The loot wants dead stuff. I guess it could happen like after health is essentially when it could happen. So I'll just put it here. Loot table, or loot, just loot. No, that's not good. There we go. Okay. So now things that have loot table should like drop things from this function. 50% chance. Let's see. Oh, what's this? All right, and Discord is here. By the way, I'd like to talk to you on a platform other than this live stream. I don't think you have an Instagram account. Maybe you don't use it as a matter of preference. I do have an Instagram. I'm not sure if it's listed on Twitch. I do have a Discord as well. Actually, let me get a link here. There's a Discord. I have 8 years of experience in software development and e-commerce design. There are a lot of scammers on Telegram, but there are also developer communities there. So I thought, why not on Instagram? I created an account 8 years ago. Right now, there are over 100 people in the group, Turks, Asian. Okay, cool. You create an account for developer community on Instagram. Nice. So, okay, so what is, like, is it for people searching for jobs, or who is it for, or just in general, like developers in general, or? I'm not sure if I'm logged in here. Okay, well, I'll check it out. Thank you. Okay, let's see if this works now. Okay, that didn't do anything. Maybe I should have put it to 100% instead of 50% chance. Why is such a big font size? Because people had trouble actually seeing the code, I guess on maybe smaller screens, perhaps. So I just decided to increase the font size, and yeah, that's it, essentially. And there we go. There's a little sword drop. Cool. It's actually in the wrong position. Did I automatically add this here? Is the question. Oh, I need to add this here. This is where I need to add it. I don't know. I think people watching on a desktop or on a large screen will be fine seeing the code. But yeah, there we go. There's a sword. Cool. Now let's do like, I could do like an equipment system. Yeah. Let's do like equipment system. So we'll grab out I guess equipped. Oops. Equipped. Now the thing about this, yeah, and they should also be on the board, which means they should have a board position. If something is not on the board, it doesn't have a board position. Okay. So we'll go through all of that. And I guess we will check if the player moved. Well, yeah, okay. How do I want this to work? So you move onto the thing. That's gonna get equipped. That should get updated immediately. Like, this is what happens when we move. We move. As part of the move action, I guess that would potentially equip the item that's there. Hey Joseph, did you figure it out? Yes! We have line of sight working now. Although it has a quirk. It's like if you have an exact diagonal line, it goes like, it doesn't go like exactly diagonally through only the ones on the diagonal. It goes like through like adjacent ones as well. Because I guess because of like precision issues or something like that. So there, you might wanna call that a bug. I don't know, but yeah, it works. Thanks for the help, by the way. The article that you linked there, and the messages. So now I'm working on like drops, item drops. And we got item drops, so that works. But I want to now, basically, if you move onto an item, it's gonna equip it, is what I'm thinking right now. Because I don't have a good idea of how, I haven't formalized the idea of how to play the game, essentially. We can move around, but that's about it. Like, what other, like, do you press a button to pick up the thing you're moving over? Sometimes maybe you don't want to equip a thing that you move over, you know, stuff like that. But right now, I'm just trying to make it actually pick up the thing. So this is what happens to the board state whenever we move. So so the only thing that happens is that the board position is updated. And I guess now we could check for equipment. Check for equipment, I guess. And yeah, let's just pass the position in because we have it, you know. Check for equipment. Yeah, we'll do it. We'll just do it straight up here. It's like we could also have it, there could be a event here. Actually, I'm not sure how I want this to work. Okay, before I don't want to make any decisions. I'm just gonna make this function here because if you do it as an event system, yes, the systems can just hook onto an event and you can like spread out the things. The thing you lose is like order of execution for one. You also lose like an overview of what's happening. But the thing you gain, I guess, is like separation of concerns. But yeah. Position is a board vector. Whatever, void, doesn't matter. Check for equipment, okay. This is like part of the action. So it also makes sense that it would be here. Because this is the action you take. It's like a, you know, like a board game. You make an action in the board game. Then this is what happens when you do the action to update like board state essentially. And so let's see. Right, so now we want to go through all of the equipped items that have a board position. Don't want to exclude anything. We'll loop through those and we'll get the item position. Is going to be this. And we're going to check if item position equals position then we're done, I think. Should we only do one? Should we go through every item? If there's like multiple items on the thing, I don't know, maybe. I just had an idea. Like, what if this is the way it works? You pick up an item. If it's better than your current item, you equip it. If it's not better, then you like it's gonna get like I guess it could be put into your inventory. I was thinking like it would be like disenchanted or something like that. But then again, how would you know if it's better or not? Then we would need some kind of heuristic to like calculate how good it is. It could depend on the situation. Like you could have a weapon that's good against certain types of enemies. Maybe you want to equip that. Yeah. I guess it depends on how complex the game will be. Okay, but anyway, if we move on to a thing, then we equip it, which essentially means that I'm gonna have a list here, items to equip. Oops. probably don't need that. All right, so if this happens, we are marking this to be equipped. And we append this here. I wonder if there's a better way to do this. We could just add like a weird, like a component. We could just add like a boolean, like to the item. Like if I do like item add true, that you can do that. And then down here, we would do another iterator that just goes through every equipped item that has true. No, that doesn't work because then we would want to remove that as well. Yeah, okay. This is probably the way to do it. Okay, and then at the end, we go through all the items to equip. And we will equip them, essentially. So it's going to be like, we need equipment. It's going to be context get equipment. And then equipment. And now we kind of need to do like a field. Trouble is, this field, this slot here is like a field enum. It's a field enum. How can you field info? I guess you would do field info. Does that have to be com time? It has to be com time. So we have to do a switch inline. I guess. Okay. Fine. So then we do like wait, what am I trying to do here? No, actually now we can do at field equipment tag name of T, because this should be, oh, it's a field enum, so it doesn't understand, right? And then this would be equal to the item. Okay, so now we've overridden the slot of where this item is. I guess what we also could do is we could check, like, if we already have an item here, slot is pointer to that. If we have an item here, we get a previous item. Now I have to do this. Oh, thank you for the follow. Cooking time. Sorry, I didn't see the name properly. I need to change my font or color or something. I barely see what's on screen. Cooksin time. Cooksin time. Okay, thank you. Thank you. Welcome. Yes, this is a pointer to a optional item. So Yes, this would dereference the pointer, and then we have an optional check out there. This would set it to the current item that we want to equip. If we had a previous item, what we do with it? I guess we just destroy it right now, as it is right now. Okay. What to do with the previous item? Maybe you'll have like a little prompt that's like, do you want to equip this or not? I don't know. It would be cool if we could get some quality of life improvements over traditional roguelikes or something. I don't know. Anyway. Yes, so we go through all the items that we want to equip. We look at where it needs to be equipped. We look at, okay, do we have a previous item there? Then we destroy it. We populate this with the item. And now we should have it equipped. Yo, 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 bro. What's up, what's up? How's it going? I need to go here for this soon, I think. So, yeah, we've been going for a while. I just wanna, okay, I'm gonna fix this, or see that we have this equipped. And then we should be good. We could also have like an unequipped, like the bronze sword, for example. When the bronze sword gets equipped, it could like change the sprite of the player, because the sprite right now, I don't think it shows like a weapon or anything. But we would know that we have it equipped because it... oh, thank you, thank you. Cookies and time cheered 8-bits, thank you. I don't know what that means, but because I'm like a noob streamer, but yeah, thank you. Don't they usually like read a message or something when that happens? I don't know. No problem, my name just means nothing. Okay. I'm thinking about cookies. Cookies in time. Like, how many cookies, how many different types of cookies has there existed through the times? I don't know. Anyway. Unused capture. All right. So do we even want this system now? Let's just remove it. Equipment. All right. Yeah, you go away. There we go. Okay, does it just work now is the question. What are you making? I'm coding like a retro style RPG. I'll show you here because I'm gonna test the next thing. So the the objective is to make this game. I guess the objective is I have like a list of visions for the game. Yeah, so you can enter the dungeon here, and we can find a weapon. Oh my god, it crashed already. Okay, cool. That at least that shows that something is happening here. So yeah, I'm just adding little things here and there. It's gonna be like a, you know, I don't know if you're familiar with like roguelikes. In contrast to roguelites. Like roguelike versus roguelite. So it's like an old school. It's more like the older roguelikes, except it has like graphics and animations and stuff. The character looks like Slender Man. Yeah, the character is from a tile set that is really awesome, actually. Which I downloaded for free from itch.io.
But I'm adding like some small things onto the tile set that I want to have in the game essentially. But yeah, let's see, where is this happening? Here, actions, move 50. We're trying to get equipment from something. Wait, did I not add that to the player? Equipment. I did add equipment to the player, okay. So, check for equipment. Well, I guess if we don't have equipment, we can't actually check for equipment. So there you go. Boom. Maybe. Okay. I think I forgot to remove the board position of the. So technically now that item that you see is the item I have equipped. If this all works, you're gonna see it in the number, the damage number, because it's we start out with damage of 2, and that should increase it. Okay, it didn't actually increase it. Let's see here. So equipped item. Let's just see if we actually equip it or not. Looks amazing. It's all thanks to the amazing tile set that I also want to spice it up, like, you know, a little bit of variation and stuff like that. It's a very early version here. Okay, did we equip it or what happened? It was equipped. Okay. Next thing I want to check, did I name the function correctly? So if we go to stats and melee damage bonus, yes, that should be correct. So we go to bronze, or sorry, items, melee damage bonus has a function called melee damage bonus, and that should be the function you should call to get the melee damage bonus. Maybe we need another. Wait, what signature do we need? If we have the method, we call it. Oh, wait. We need to go through. No, we are going through the equipment items. We're going through the. If we have the method name, we call it. It just needs the component itself. Equipment has. Oh, equipment does not have the melee damage bonus. Maybe we'll have a special function that like if you want to get stats from me, you should go through this portal first, instead of having to implement all of these separately. Yeah. So, like, I guess we'll have a function get value. Okay, let's see. This is like a super generic function here, where essentially we're going through all possible components, looking through their types to see if they have this function that you're interested in. For example, melee damage bonus. So if any components have that method, then we try to get that component and we call the function to get the melee damage bonus of this component. So that everything that has the function melee damage bonus will get called and added to the sum here. and then that gets used when determining your stats, essentially. So it's like it's sort of like a, I don't know what to call it, like an interface or whatever. But yeah, we're going through, it's like automatically going through all the types and checking if it has the function name in as a method, and then we try to call it and we add it there. So but what I want to do here is I want to basically have like a, I guess, an override of this functionality. So this would give us, I guess it would give us t, and but now we need self as well. And then this is like, do I have this on like board stats value? Oh, operator, function name, entity context. So instead of having these functions, we can just you know, implement this interface sort of function instead. So whoops, let's actually copy this, one of these. Okay, now we're going through the thing. Yeah, I mean, I guess we would do the same thing, really. We'd have like a value, and then we'll do like the operation. You know what? Let's just do this. Apply a, or left hand side. I guess this would also have to be a comp time t. Or this could be an any type, to be fair. Yeah, right hand side, type of left hand side. We would get a type of left hand side. Okay, essentially. I mean, there could be possibly other things as well. But we'll just return switch self sum left hand side plus right hand side product. Okay. So now we don't really need to implement that. We just need to have, oh yeah, we need the identity as well. What is this called in mathematics? Identity of, we need, and then we need a type. I guess we actually need a type here. And if it's the sum, it's 0, and if it's product is 1, that's the identity. And so this would be op identity. And here we're gonna do operation apply. Actually, it needs to be like this. Yeah. Wait. Well, actually, well, I guess it doesn't have to be, but I guess we can also do this, right? Okay. So now this is a context. So actually we can do like, now we can do game board stats get value again with t operator function name context. Actually the context now is item instead. So this would be the item value. There we go. Because you are a, well, yeah, cool. So we're going through all the slots, which are these ones, because everyone is a optional entity, essentially. And we get the fields, and we just access this field, and we check if it's optional, if it's null or not. And then we, if we get it, then we calculate the value that we want to calculate, if it's melee bonus damage or whatever it is. And we apply to this operator, and then we return the final value. So there we go. Also, thank you, Osan, for follow. Thank you. Welcome, welcome. All right, cool. So we don't need the context, I guess. Okay, sure. But this would follow the interface. We need self, yeah. Okay. So now let's go to stats, and actually get value should now like check. Okay, well, does the type, or yeah, actually here, do you implement the method? Then we should probably call it. That should be like an override. But there could also be, do you have a method called, and this is, you know, meta here, function name. Like this is just a function name here, get value. I don't know why I put it there. Let's just do that. Okay, so if component has the function name, then we also try to call it. Do I have to put com time here actually? Let's put com time here just to make sure. Because yeah, otherwise you might run into issues, I think. Well, anyway, then that means it has a get value function. So we try to get it, and we also try to call then. Now we don't have to do field, we can just do component get value. And we have to pass in a bunch of stuff. So we have to pass in like type, operator, function name, context. Wait, what's going on? Type, operator, function name, and context. And there we go. Well, actually, a lot of this is like the same. So I guess we could do like an or here. Has function name. Or has get value. Then this is gonna depend on the thing. So basically, if comtime has function name, we want to set it to that. Otherwise, it's gonna be the other case. Oops. I know it can auto format for me, but whatever. Actually put this up here. This is probably the only formatting thing with Zig that I don't like. Like formatting this, I would rather have this on a separate line, because then it's like symmetric, and also I can, you know, remove this. I can switch them out without this changing meaning. If I do it now, it's like it messes up everything. Oh, thank you for the cheer again. Cookies and time. 2 bits. Thank you, thank you. Awesome. Man, today's stream has been probably the most active stream. I'm not sure how much time I have left here, but we'll keep going a little bit until I'll get thrown out here in a second. So, right, and now we can remove this whole branch here. Okay, and now we don't have to repeat this this thing. Although, now that I think about it, value should be equal to operator apply value next. There we go. So then we don't have to actually do that either. There we go. Okay. Wait, are we done? Like sometimes your brain just, after you've done a whole thing like this, your brain just empties out everything and I don't really know what's happening anymore. Did it say it was equipped? I'm not sure. Let's see how much damage we'll do now. Only 2. Okay. Still only 2 damage. Okay, so we're missing something here. Let's check if we are calling this function. Also, let's go to melee damage bonus and check if this actually gets called as well. Calling melee damage bonus on melee damage bonus. I mean, it could be that we're just not applying it as well. Perhaps. I think we are though, because the strength bonus is actually added. Whoops. Okay. Yeah, all of the goblins updated thing. Equipped item. Okay, so item is equipped. Here's a mage. Well, it didn't deal more damage. And nothing says melee attack. Does anything say get value? No. So this wasn't called. And we didn't get compiler errors. Huh. Okay. What's kind of funny about this is that when you're using like ECS, your weapon can have an equipment too. So it can be like recursive. Your weapon equips you. That will be an infinite loop. If the thing has thing, otherwise call the thing, and there you go. I don't know if we can log this out. We probably can actually. Has get value for type name is equal to this. Type name of component is equal to has get value. If we run this, it's gonna show at some capacity. Like every time we try to hit something, it's gonna show. Yeah, I know you want it to be removed. I'm gonna remove it soon. Hasket value. Is this even called? Hang on. Let's go to melee attack. On create. Damage bonus. We get the stat melee damage bonus. Okay. This gives us. This calls this. Why is this not? Oh my god. Okay. Sometimes I press start game 2 times. So you get another instance of the game and I don't notice it. And I exit the game and I'm like doing some updates to the code. But then it can't overwrite the executable because it's like running. So any changes I make to the code won't get like updated. That could be the reason why things are going wrong. Maybe. Now we get a whole bunch of stuff. Okay, so let's see if we get the extra damage now. No, we don't. Okay, but we do get a bunch of logs here. Hot reload. Now I don't have any hot reloads. It could be like potentially implemented, but I don't have it right now. Yeah, there's no built-in hot reload in Zig, as far as I know. All of these don't have the thing. Oh, it actually says that this doesn't have get value. That's right. But equipment. Oh, interesting. It doesn't say. It says it doesn't have it. Huh. I wonder if we just do this. Did I misspell it? Maybe. No. Okay. Maybe function name added a bunch of other stuff there that we didn't see. I have to make it yourself. Yeah, exactly. Which, I mean, it could potentially be generically done through the ECS components. And also, since this is kind of like a board game, maybe it's going to be even easier. There we go. Now it works. Cool. Oh, wow, that's a lot of dodges. Okay, nice. Did you just go through the wall? I don't think I did go through the wall. Well, you can go diagonally. Although the monsters seem to be able to spawn in the wall. This guy, for example. Also, he can hit me from there. What's going on now? It like lags. Sometimes it gets stuck. I'm not sure if it's the line of sight algorithm or something else. But then usually it breaks out after a while. This is kind of different. Okay, well, we don't need to log this out here. I'm gonna check all the logs. What is this? Oh, this is the test file. Equipped item, we can remove that. We have this attack logs, we can still have that, I guess. Sets animation, don't think we need that. Calling melee bonus damage, yeah, that seems to work. Yeah, that also seems to work. We have map, bunch of logs here. I don't think we need this anymore. Entity active, sure, why not? But this is like kind of flooding though. We don't really need this. Okay. Also, let me get rid of that. So now it's only melee attack and this stuff. I'm not sure what this is. Sounds like events. Okay. Okay, so let's make the item disappear. Yeah, I think it was in the move action. Items to equip. We don't want to remove the item because the item is essentially its own entity. So we want to have the item is still going to keep its like components, except we want to remove like we want to remove the board position, because board position is like, if you have board position, that means you're on the board. If you don't have board position, you're somewhere else. And in this case, you're equipped here. I guess that's it. Well, actually, we want to remove body as well. And renderable. And possibly animation, if it exists, I guess. Yeah. Okay. Well, I guess renderable. I mean, I guess we could still render it if we show like the, maybe we can show the equipment. Okay, there we go. Yeah, okay. But now when we remove body and renderable and animation, it actually disappears. We just remove board position. I think that when the move is done, we have to kind of do something here. Actually, yeah. It doesn't matter right now. You know what? I'll just put this here because the thing is, like, I want the animation to update and then, or I mean, what I'm saying is this update that I'm doing right here should only affect kind of the board state and not the what you see. So what you see is not the current sort of board state. What you see is like, you see like the animation that it gets replayed like after an action has been taken, essentially. Except for when you are the player and it's waiting for you to input an action, then you see the current board state. But as soon as you press a button, then the board state gets updated, and you might have, like, essentially all the other enemies make their move. Not at the same time. It's still in sequential order, but we kind of show like all the animations, which you can more easily see here. It's kind of hard to tell where the goblins are, but you can see if I do something, they all move at the same time. It looks like they move at the same time, but actually they are kind of moving sequentially. but I'm playing the animations immediately. I'm taking a lot of damage, and there we go, I'm dead. Okay, but that's gonna be it for this time. Thank you everyone so much. Wow, this stream has been the most active this time around, man. Thank you so much again for all the subs and the follows. And the cheers, or whatever it's called, the bits. Yes, have a nice day, everyone. Let me send you off somewhere as well as the last thing here. Do we have any zig links left? Is the question. We do have a zig person, but it's in French. Wait, is this even zig? Neovim Godot? It's like perfect, except it's French. Do you know French? Okay, let's just check. No. No, me neither. Portuguese. Oh, this looks cool. No Gen AI. I'll check. Okay, we'll try this again. No, background development. I'm not sure what this means. Okay, let's do this here. Programming. Something, something. I don't know. Let's go. All right, have a nice day. See ya.